This conference will now be recorded.
Hello everyone, welcome to our day 13 GCP Cloud Architect training. Yesterday we stopped at this slide where we were trying to understand the various input-output source. I also shared one of my real experience. So it's very important you figure it out by just going to this official website, beam.apache.org documentation/io/built-in to find out what are the currently available input output transforms available. Based on that, you decide how long implementation or data pipeline takes. So if it's all built in, it's going to be a little short time, but if it's something a brand new like the one which I was saying like yesterday, the um, PubSub Lite or REST API, you have to build something. You, in the sense, the data engineer, have to build it. So it's going to take longer time. So this is going to help you out to find out whether there's any built-in or extra. So, and you can also say this to the customer, substantiating your reason why this pipeline takes a longer time, basically. So from yesterday, we have been talking about Apache Beam pipeline, all those things. So how does a pipeline look like? If you wanted to know, I have a small screenshot. This is has to be in a code form itself. So um, batch data processing pipeline looks like something like this. This is in Java language. So I'll show you one more example in a Python. So most of them looks the same. Basically, you create an object called as uh, pipeline, and basically you read from a source and write to a destination. That is the basic stuff. And in between, you are going to do some transformation. For example, here they are going to read it from a text IO, which we saw here. This is a text IO. So you're basically reading it from a Google Cloud storage bucket. Read it and do some processing in a parallel fashion. So in Apache Beam, everything is going to be in a parallel fashion. That's where you call it as P transform, P collections, all those things. So basically, it's going to be in a distributed fashion. So first you do some grouping, afterwards you do some filtering, then you do some transformation. At the end, write it back to a destination, which in this case is again Google Cloud Storage. Now, whether you are going to do a batch processing or a stream processing is all decided by this input source, input or the source. So if the source is something which supports only batch, it is going to be a batch processing. So Google Cloud Storage supports only batch data. So it's going to be basically a batch processing. So if you want a stream processing, as I mentioned, the code base remains almost 95% same. So not much change in the code base. It remains almost the same except the input. Now, instead of a Google Cloud Storage, what could be a component which you can use, folks, to make it as a stream processing? Instead of text.io, what could be the possible source which you can use for streaming? Basically, any one of these things in this category. In this third column, if you use any one of them, it's going to become automatically a stream processing. And since we are taking learning GCP, the product which we will focus is PubSub. So if the input is a PubSub topic, your job automatically becomes a stream processing pipeline. So how it looks like? It just looks like this. Only one or a maximum two lines is what you are going to change basically in the same pipeline. So instead of reading it from text.io, you read it from a input output transform called as PubSub read from a specific topic. And you are going to have a small extra line for processing on stream. So usually what happens is, if I can take my highlighter. So if it is like a stream of data, right? These dots assume these are data. Now, if the stream continuously flows, it becomes very difficult to process. So what we do usually in stream processing is we put a window of 30 minutes. whatever comes in this window, only that I'm going to process. Why you put a window? Because when you put a window, it's going to have a start and an end. So now it becomes like a micro batch processing. So that way your stream processing becomes easier to handle those things. So that's where there are different types of sliding, different types of windowing functions which you get: fixed window, sliding window, session based window. Lots of such things are there. So only these two lines are the one which changes, and this is the one which is going to decide whether it is a batch or stream. So that's only one line which is going to decide basically your source. So if your source has that capability, it can become a batch processing or stream processing. So in GCP, if you look into the documentation, they very clearly say the job can be the data flow pipeline can be a stream processing only if the source is PubSub or BigQuery. That's it. Nothing else is going to be supported for stream processing. Batch processing, it could be Spanner, Bigtable, Google Cloud Storage, BigQuery. Lots of options are there. So now the big advantage of Apache Beam, this is an Apache Beam pipeline written in Java. So, and when Google open sourced it to the Apache Foundation, they gave only the Java version of it. Later, the open source foundation built Python also. Now they are working on Go language also. So the popularity wise, if you see, Java is a better one if it is streaming. So I have also done a few implementations on stream pipeline, primarily using Java only. Um, so as a cloud architect, you don't need to write a code, but if there's a requirement where they say it has to be written in Python, make sure you consult a data engineer, because certain features in Python are not fully available. So slowly it is maturing. The mature product when it comes to streaming is going to be mature language, I would say, is Java. So that's an important thing. So now the advantage of having a unified programming language, the advantage is, yesterday we were talking, Anil B also had mentioned about this, like having a policy. Now assume I need to bring in a new policy, meaning after you read from the source, I don't care what is the source, but this transformation, right? After transformation one, I want to do one more transformation, which has to be common, which has to be common uh, across all types of pipelines which you are going to. You may have n number of pipelines. So if I were to bring a common transformation, and if I have written in one language, it's going to be easy for me. So this batch processing and stream processing both can be done by one single person itself, because it's only few lines of code which has to be changed. So this way you can have a common change rolled out to all the pipelines. So that's the biggest advantage of Apache Beam pipelines. So how a Python code looks like uh, is something like this. So this is a Python code. I use the same thing in my data engineering training. So where you mention, this is in Python, you mention I want Apache Beam. What are the stuffs you want, the modules? You take it. Basically what I do here is, this is my pipeline. So the same format, only the syntax is going to be changed from Python to Java. You read your pipeline options. First, read the data from Google Cloud Storage. So beam.io, text.io, read it from a storage. Then do some transformation parallel to, then basically write it into BigQuery. So this reading from Google Cloud Storage, doing transformation and writing it back to BigQuery. What is this kind of pipeline called, folks? Batch processing or stream processing? Based on what you have learned so far. So storage, transformation, and BigQuery. Is this a batch or a stream processing? Yes, it is going to be a batch processing. The reason is is going to be batch processing. The reason is the source is Google Cloud Storage, folks. It cannot be a stream processing. Stream processing in GCP can be only from PubSub or from BigQuery. These are only two services which can support stream. So anything else is always a batch processing. So this is from batch processing. basically. Okay, so this is a batch processing one written in Python. Now this is a piece of code. Now everybody knows if there's a piece of code, you need to have a specific library, all those things. So one of the runtimes, a library, necessary libraries, and a system to run. It could be your local system. If you are using local system, it is going to be basically, if I go a couple of lines back, slides back, if it's your local system, you have a Beam pipeline, a piece of code. That's it. So, which is going to leverage the Apache Beam model, the unified programming model, all the formats. Now, if you were to do this parallel distributed computing, all those things, you have to write lots of code. Instead of using this library or this framework, the amount of lines of code which you're going to write is going to be less. Now, you have the code ready. Now, you have to test it out. What you will do? Usually, the data engineer first tests in his or her laptop using direct runner. Direct runner is basically nothing but your local machine. So in the local machine, it's going to be one system. So the parallelism may be very, very limited. So if you want to have something like auto scaling, all those kind of a feature, you have to use any of these other execution engines or runtime. One of the one which Google offers is Dataflow. Now, Apache Beam pipeline by itself is platform agnostic, so or cloud agnostic. Tomorrow you don't like GCP, you don't need Dataflow, no problem, directly run it on AWS EC2 instance by just installing all the necessary modules. That's it, you are going to get those features there. So that way you don't have any vendor lock-in with your data, with your Apache Beam. So one of the vendors for your execution engine is going to be Dataflow. You don't like it, and you will see it in today's demo. Dataflow at the end is nothing but a managed instance group. At the end, nothing but a virtual machine. So the same thing you can do it in your AWS, Azure, any other cloud. So that's the key part here. So no vendor lock-in. Openness. So the difference between your batch and stream processing is going to be basically controlled by your input. So it has to be the PubSub or BigQuery, and we are going to do a similar demonstration today, stream processing only, but we are not going to write a single line of code. There's a cool feature which you can use in Dataflow to do that. By doing this, we are also going to learn the concept. So this is going to decide whether it is stream or batch processing. Now, a typical streaming architecture looks something like this, a very busy slide. So let's go slide component by component and try to understand, and we'll try to do something similar when we finish it today. So first of all, the input could be some kind of a stream. So it has to be some kind of a sensor, an IoT device, or a mobile device itself, which keeps on sending some data. So it keeps sending some data. That's your trigger. So those kind of information reaches first PubSub because it's a stream processing. So the PubSub, so these are sent as a topic. Sorry, message. It's going to reach the PubSub topic. Once it reaches the PubSub topic, you need to do some enrichment. So you may send it in a JSON format. You want to transform it into rows and columns because in BigQuery you want to insert in rows and columns. So you want to do that transformation. JSON to tabular form is one transformation. In that, if you were to do further transformation, for example, maybe there is a name, you want to split that into first name and last name. So n number of transformations you can do it. There you are going to use Apache Beam pipeline, either in Java or Python. You do that, then run that pipeline in Dataflow for doing all your enrichment process. Once you do that, that's your ETL component. Basically, it extracted the content from PubSub, doing the transformation and loading the content into your BigQuery. So into your BigQuery. So basically, PubSub, Dataflow, BigQuery is going to handle your stream processing. Once the data is in BigQuery, which is our data warehouse, you can basically visualize it using the BI tool of your choice. Power BI, MicroStrategy, Tableau, Click, any of the tools, because most of these BI tools provide you an option to connect to BigQuery, or Google also has its own free BI tool called as Data Studio. Visualize it, and you can see the entire stuffs in the UI very nicely. So what we will do basically is, in our demonstration, PubSub, Dataflow, BigQuery. The pipeline is already written. We are going to use something called as template, and use that template and do it. So this is what we are going to focus today. And this is really an important architecture, very, very important architecture. We will revisit it one more time. So maybe next week we will revisit it one more time for doing one more demonstration, which is relevant to Teramath case study. Okay, so one of the case studies, so where you are going to use IoT core, you are going to use IoT core. So now, with 5 components, I can finish both batch processing and stream processing. So if it's stream processing is what you need, basically I go with this component. This is going to be batch processing. So this is my batch. Why it is batch? Because the source is a Google Cloud Storage bucket. Now, if you want to do stream processing, PubSub, Dataflow, BigQuery is one option, or PubSub, Dataflow, another PubSub. That is also a possible option. So the source is the one which is going to decide me. So just using Google Cloud Storage, PubSub, BigQuery, and Dataflow, I can achieve both the types of data processing easily. And the biggest advantage of this kind of combination, anybody wants to share what is going to be the big advantage of this kind of a combination, folks? Google Cloud Storage, serverless. PubSub, serverless. BigQuery, serverless. Dataflow is also serverless. You don't need to much worry about it. So this entire stuff is based on serverless. So your operations works is going to be very, very less, or sometimes you can easily say no ops. So you can have a ETL job with no ops, basically. This is the biggest advantage. So this architecture is very, very important. From the examples, any stream pipeline, the only architecture which should strike you during the exam time is PubSub, Dataflow, BigQuery. This is totally serverless. So that's an important thing. Now what we will do is we'll try to do stream processing, and you can give a try for batch processing yourself. I'll show you how to do that. You can do it at your own pace. Give a try. It's going to be a good exploration, but I'll take the difficult one, which is going to be stream processing. Batch processing is going to be easy. So you put it in Google Cloud Storage. So you put it in Google Cloud Storage, some CSV file, run a transformation. It's going to be inserted into BigQuery. But PubSub is going to be a little difficult. So where we are going to simulate some data, send it continuously, it's going to be transformed and then inserted into BigQuery. So we'll do that demo now. So for this, we need basically 3 components: PubSub, Dataflow, BigQuery, and we are going to have also simulate some data. So, but the main component is Dataflow, and Dataflow, to use it, you need to write a code, and we don't want to write a code and mess it up. What we are going to do is, instead of that, we are going to use a template which Google provides. There are lots of such templates. The reason why I'm using template is 2 reasons. We don't write code. That is one reason. The second reason is, if as an architect, sometimes you are expected to do a proof of concept, uh, 2 days, 3 days proof of concept. At that time, you cannot say to your manager, to do this piece of code, configuration, I need a developer who is well versed with Python or Java. 2 days, nobody is going to give billing within your organization itself. So you would have known that basically the billing stuff, right? So at that point of time, instead of writing a code yourself, leverage these templates. I use these templates very effectively to do proof of concepts. So that's the reason I wanted to highlight and show you this part, how you can use templates. So for this, first let's explore how our data flow looks like. before you enable it, for some of the services in GCP, I have seen if you have not enabled the service, for example, our compute engine, we did not enable the compute engine API explicitly in our beginning days. We just went to compute engine, it enabled an API automatically, right? But Dataflow API does not get enabled automatically. Even if you go to, so we are going to use PubSub, Dataflow, BigQuery. I'm just spinning them so that I can easily save some time. And we will also use storage for some specific requirement and uh, compute engine. So these are the components which you are going to use basically. So if I go to my data flow, first time we are going into it, it shows something like this. It shows something like this. The problem which I have seen with data flow is it shows like this, which gives an indication that the API is enabled. For example, so it gives like it is something enabled. Some of the services, for example, we may discuss about DataProc today. So if I go to DataProc, how the screen looks like, this is a mistake which many people do. That's the reason. So if I go to DataProc, let me see whether it can show. No, not this one. Let me take Data Fusion, another product which we are going to talk. Maybe this one, project is not enabling redirecting. Yeah, this is how it should show. If I go to DataProc, meaning API is not enabled, you show that enable it. But when it comes to your data flow, it does not show anything like that. It shows as if like the API is enabled, but literally the API has not been enabled. How do you verify it? Simple. Go to your APIs and services library, and when you search for data flow, the data flow API shows up and it shows it is not enabled. So there's a bug in the UI, so don't get confused. So if you start doing everything, the steps which I'm going to show without enabling the API, it's going to throw an error when you submit the job. So first, this is a bug which I have seen. So I've done many times, filled all the details, then clicked, it does not work. So please enable the API first and do it. Now, the reason for sharing this again is in the future, if there's going to be some kind of an infrastructure as a code going to be configured, that too it's going to use data flow. Basically make sure the API is enabled. So like in Terraform or in deployment manager, which we are going to talk in our 8th module. So make sure this is enabled. Now the API is enabled. Yes, it is enabled. Now if you want to just verify it, you can again go to API and services library, search for data flow. It shows the API is now enabled. Awesome. Now what we will do is go to data flow. We'll not write any code, but we will leverage this option. Create jobs from template. We are going to create a stream processing job using the template, and there are good amount of templates. You'll be really surprised to see this much of templates, and you can use this as a base, at least for your proof of concept, and modify it based on this. And to be very frank, currently I'm writing a book where there is primarily on stream processing, data stream processing requirement. It's a very small book with live implementation kind of a stuff, where I just use this itself to do the write that book, online book. So basically, so that's how easy it is basically. So let me try something like batch 6, or let me put it like this one: PubSub, data flow, BigQuery. This is what we are going to use basically. And this is data flow templates. So data flow templates, if you see, look into the details, it shows as if like it is a regional resource, but it's not really a regional resource. You will come to know later that it's not a regional resource, it's a zonal resource, because it relies basically on virtual machines at the end. So what I will do is I'll choose Singapore as the endpoint. So sometimes you need to access the Dataflow API. So the APIs or the endpoints are made available in these regions. So I guess uh, in most of the regions it is available. So now if you want to know whether the service is available in every region or not, the easy way to do it is just going to the regions and zones page, which we have seen many times. So we just stop either looking at the regions or the network. But if you scroll down, right, you get a good set of comprehensive document which says what product is available in which part of the world, the 25 regions. It shows that very nicely. So if I look for data flow, yeah, data flow. Now, if you see the tab is on Americas. So if you look into this data flow, data flow is available in all the 7 regions in Americas. Now, if I go to Europe, data flow, yes, it is available in all regions in Europe and in Asia. It is available. So it's available in all regions. But if you see, there are some products which is not available in some parts of the region, but it's a different product called as Cloud Composer. So this green tick is going to be really helpful for quickly for you to figure it out. Instead of you relying on the user interface, I would say I will do both the stuffs, which sometimes the user interface is up to date. This may not be up to date. So I cross reference. I usually take 2 or 3 doc as a reference point. One, the documentation, one, this page, a quick stuff, and go to the user interface and see whether I see that region or not. Whenever I'm creating any documentation that this is the resource where it has to be created, I use that option. So currently it is available in Singapore. I'm going to use that. And this is the most important part, where you see the various templates available in supported by Dataflow. The most simplest one is going to be called as word count, where this is the most traditional one. If you have used Hadoop, the first sample program which would have run is word count. Basically, you're going to have a file or something where it's going to count how many words are there in a distributed fashion. It's going to do this in a parallel mode. So that's the same thing which you're going to do. So you're going to read it from a storage bucket, do some transformation, read it, then write it back to a Google Cloud storage bucket. So this is batch processing. So the input is a storage bucket, output is again a storage bucket. So parallel processing, I would suggest you to try this. And there's also a nice tutorial. It shows you here. So if you just click on this tutorial, step by step they guide you how to do this basically. So follow this and try to do it. If you have any challenges, I can help you out in the next class. So it's a very straightforward one. That's the first one. And there are 2 types of categories they give. One is process data continuously, stream jobs. There are n number of stream jobs which you see, and there's n number of batch jobs which you also see. So Avro file on Google Cloud Storage to big table. So lots of stuff. So you will also have some converters also available, utilities. So if you just go back to our BigQuery, we had figured it out. BigQuery, the data, if you load it as Avro, it's going to be the best data file format which loads faster, we had seen. But if you don't have any connectors or anything to do that, you can use Dataflow. So Dataflow has some utilities which can convert file formats, Avro, between Avro, CSV to Avro, that kind of a stuff. There are utilities, built-in utilities. You can use Dataflow. So good amount of use case is going to be there. So I would say to spend a good amount of time on this templates. So any POC comes or anything, make sure you just come explore this templates. There's a possibility that the templates can fulfill your requirement. So the template which we are going to use today is going to be under stream processing or process data continuously stream. So the one which we are going to check is PubSub topic to BigQuery. And there are two types: PubSub subscription to BigQuery, PubSub topic to BigQuery. I'm going to take the first one, topic to BigQuery. The reason is, if I use PubSub subscription to BigQuery, I have to create a topic and I have to create a subscription. Then only things is going to work. I'm going to be a little lazy here, so I'm going to use PubSub topic to BigQuery, by which you will see the data flow pipeline is going to create automatically a subscription for you. So that's the option which we are going to use. So when I mention this template, it gives me a graph, usually called as directed acyclic graph, DAC, where it shows the entire process: read from a PubSub topic, convert the message into a tabular form, rows and columns. If it is successful, write it into BigQuery. And that too, it's going to be a streaming insert. So if you remember the BigQuery pricing calculator, it had an option of inserting data. Batch load we had seen, batch upload, it was free. There was an option called a streaming insert, which was little expensive. So the streaming insert, so you can go up to 10 MB of streaming insert, 1 GB, 1 terabyte. This is going to be free. But the moment you have more streaming insert, the price starts ticking in. So there are many implementations where people have not used streaming insert just because it is little expensive. They somehow convert the pipeline to batch processing. But in our case, it's not going to be too expensive because we are going to do a very short demo. So we'll see that stream processing also. So it shows that streaming insert, and there could be sometimes some error handling is also going to be handled by the system, and it's going to write the failed record into another table in BigQuery. So if it's successful, it's going to write into a table, a specific table. If it's an error, it's going to write into another table. So this is how the entire pipeline is built, and it's in a template format. We don't need to write any code. We use a template. And if you're interested in knowing the actual code, it is in the GitHub page. I can show you that towards the end of the demo. So the prerequisites are, you need to mention a topic, a PubSub topic, a BigQuery table, which is going to be your destination, and a temporary location. To do this, basically. That's it. So if you do all those things, your stuffs are going to start working. So let's create a PubSub topic, BigQuery table, which is an empty table, and a temporary Google Cloud storage bucket. Once we do it, we should start the pipeline. So let me go to my PubSub topic. So there's a topic which we already created yesterday. If you want, you can delete it, or you want to use it, same thing, you can use it. For the demonstration purpose, I'm going to use a new one. And yesterday we had created 2 subscriptions. So I'm going to delete those subscriptions. So this one was created by me manually to do the pull. And there was one more subscription which was created by the cloud functions. So if you delete the cloud functions, this this subscription, which is of delivery type push, is going to be automatically deleted. So let me just go ahead to my cloud functions and delete it up. And if I leave it like this, it's not going to cost me anything because it's serverless. So I should not have any issue, basically. But let me make it as a clean slate so that when you do this demo, it's going to be really nice to do this part. And we'll try to make this demo more comprehensive so that all our stuff so far, IAM, networking, all the concepts we'll try to put into this, because 3 components, for the first time we are using 3 components. Let's try to make it as comprehensive as possible, or maybe we can have it in 2 flavors. One, the most basic version of it. Once you see the stuffs are working, we'll try to make it more comprehensive. Second time run, maybe when we do the IoT core, we'll make it more comprehensive so that you will see how we can have the best practices of it. So now cloud functions deleted, meaning the subscription should also be deleted. Basically, that's how it should work. It is not deleted. Okay, deleted. So I just refreshed my screen, it is deleted. So no subscriptions, just keep a note of that, and no topics. I don't want this. Making it a clean slate, that's it. Done. So what I'm going to do now is I'm going to create a PubSub topic, brand new one. I will make sure I don't check this box. When you do this demo also, make sure you don't check it. There's a specific reason. Just wanted to show you that Apache Beam pipeline, whenever it starts, it creates a subscription automatically, like how Cloud Functions did. Dataflow is also going to do the same thing. So Dataflow, where the code is written in Apache Beam. The Apache Beam, to be very frank, that is the one which creates a subscription. And once you stop this job, it's going to delete that subscription. So everything is going to be like on demand. So let me call this as streaming topic created. Now there's no subscription, and I'm not going to create a subscription because Apache Beam running on Dataflow is going to do it for me. So just to show you, it does not have anything. So what I need to have is just the name of this PubSub topic, which I can copy to the clipboard, go to my template. So I just paste it, job done. So my topic is there, and they also give an example. It should be project slash your project ID slash topic slash your topic name. The next input, which or the next the next parameter which you have to give is the source, sorry, the destination, which is going to be your BigQuery table. So for this, you have to spend some time understanding what kind of data is going to come and what kind of schema I have to create it. So for this, what we are going to do is we are going to use a gaming application which is going to continuously stream the data, and we will see how it gets inserted. So I have a small piece of code. The code is already uploaded in your module stick called as pubsub.py. You can download it. I have it in my Cloud Shell. I'll just open it. So because when you create a table, right, BigQuery table, you need to basically create with some schema. So the schema which we are going to send is going to be something related to our case studies which we are going to talk. So basically, let me remove this line. I'll tell you what this code also does quickly. Okay, so there's a Python code where I'm going to use my client library called as cloud.google.pubsub. So I have to install this module, which is not installed. That's the reason I see this error in my Cloud Shell editor. So I have mentioned my project ID, and my topic is this one. This is my topic, and what I do is I run a loop, a for loop for 20 times, where I'm going to send some information like player ID, the score. It's like a multiplayer game, folks. Player ID, the score which the player is gaining, and the actual name of him. So these are three parameters I use. I send it in a JSON format. I send this in a JSON format. I publish it to PubSub. Yesterday, if you remember, we were manually inserting the data, which was not a good idea. And today we are going to use a code uh, as more like a simulator to send this kind of data. And you can run this 20 times, 100 times, or you can run it in an infinite loop, your choice. So we will run it in 20 for 20 times, or if you want to run it for 30 times, we can do that also. So basically the format is player ID, which is going to be basically a string. In my case, score is again going to be a string. Let me just run this just to see how it shows. Uh, Let me run it for a couple of times. I have only the topic. So when I do PubSub Python 3, it's going to show me an error like this module is not there. Please install this module, which is not there. So because it's a Python, you have to run it with a specific install package manager called as pip install cloud dot. I don't remember this. Let me just copy this PubSub pip. So if I do it, it's going to take me to a page where it says you have to install this basically. So let me copy this. So this is the module which I'm going to install. Done. The module is installed now. If I edit this file, uh, it should have shown a better message. It should have shown that error message should have gone actually because we have the module installed. Okay, that error message which you were seeing, it's gone now. So this editor is really cool. It shows you those syntax highlighting all those things and errors. So now the module is all good. Now what I will do is I'll just do Python. So this is the only place time where we are using some code to generate this thing. So authorize. So this is what I'm going to get, folks. This is the kind of data which I'm going to get. So basically looking at the JSON format, you'll understand player ID is a numerical or an integer data type. Score is a integer data type. Username is basically a string. So I have to create a schema like this. So what I will do is basically copy this. And if you want to see whether this is a valid JSON or anything, you have lots of tools, online tools, JSON validator. You can put that and see whether I usually do this because sometimes we'll make mistakes. So validate, it's a valid JSON. So you have to send it something like this format. You are all good. You're all good. That's what it indicates. So I have to have a BigQuery table, which is going to have player ID, which is integer, score, which is going to be integer, and username, which is going to be a string. So let me create a empty table under my because I'm going to do everything in Singapore, so this data set should be good enough. So I'm going to create basically an empty table. Let me call this as gaming data. And very important, folks, please either create your table name with without any underscore or any hyphens, one single name. Readability is going to be becoming difficult, but if you want to have a better readability, please use underscore. Don't use hyphen. That too, when you're doing this kind of stream processing, it's going to have some issue. There's some issue with the hyphen. So I had done this once where I had put this and I was waiting, the data was not even getting processed. Then searching in the net, one of the Stack Overflow uh, response told that if you're doing streaming, don't use under hyphen, use underscore. From that time onwards, I made sure the names are always underscore, not hyphen, the table names. So I need to add a couple of fields. The first field is player ID, which is integer. The second field is score. The third field is user. So this has to be string. This is the thing. So if you see, this is my schema. Basically an empty table is what I'm going to create now. And if you want, you can turn on partitioning, all those things, but we'll keep it as simple as possible. We have learned the concept, and you can use partitioning here because there are integer data types. So you'll get basically player ID and score as your partition IDs possible, but we will keep it simple. That's it. Just based on what kind of schema you're going to use to send it, you create your what kind of data you're going to send. Based on that mapping, you create a schema equivalent to it. That's it. Click on create. Now I have an empty table. So if you look into the details, it shows you 8 details, 0 rows. Preview is going to show empty. Now I wanted to show you a couple of differences. What we usually do is bulk uploads, all those things. Maybe I'll upload a couple of data. Okay, I'll just upload a couple of data in CSV format and just show you how the data gets loaded. So I'm going to use this itself just to show you some difference between stream processing and batch processing. So if I use my notepad, I'll just call this 32. So this is my data, folks. Basically one row only. So I'll call this as game batch dot csv. So I have a small file. So what I will do is, if you want, you can load this into your this table. So either you can use your user interface, do that append mode, or use your terminal. So I'm going to use my terminal. So I'll just upload it, trying to use all the concept which we learned so far. So I'll upload my data, and you now know how to load a batch data, right? So we'll use that concept. So my file is game, it is there. So if I do bq ls batch 6ds, I'm going to use this data. So bq load batch 6 underscore ds dot my table name and my file name. Things are all fine. It should get inserted properly. Done. If you want to query it, you can query it here itself. Select player ID from okay. Why this error? Basically, if I run this, it again shows the same error. Basically, this is because you have to use legacy dialect and you have underscores, all those things. So make sure you use this. Is my table wrong? Oh, sorry. My bad. I had put this one also. It should work now. Yeah. Yes, the information is inserted. You can also query it in your this thing. So if I just refresh it, so if I click on details, I'm going to take a screenshot of details page, folks, for a future reference. So this is the one which we have. So nothing else. Now if I click on preview, it's going to show me one row. Now what I have done, this is batch upload. This is totally free. Good. Now I'm going to use this table details into my this thing. So remove the white space. So they give that example also, your project ID colon your project data set name dot your table name. That's it. So the input and the source is configured, and because it's going to be some batch stream processing, there's going to be a temporary storage it requires. Even here, our best friend Google Cloud Storage comes into handy. So it expects a temporary location. So you have to mention a bucket name with this format. So let me create a bucket, and this is going to be for some kind of a data processing. So what kind of storage class I should use, folks? What kind of storage class I have to use? This is going to be a batch process, sorry, data processing. This is not for some serving data with lowest latency and all. So what kind of storage class I have to create? Any thoughts? Beautiful. A regional storage class as per Anil B is the one which is going to be good one. So I'll just generate my online GUID. We know we should not use project ID. So we are going to use some best practices wherever possible. So I'll just add this word streaming. Now, as per Anil, it has to be a region. It should not be a multi-region region, and I'm going to put it in the same region where my processing is going to happen. So now if you see uh, PubSub global, no need. My data flow is going to run in Singapore. My temporary storage is going to be in Singapore. My BigQuery data set is going to be in Singapore. So same region. The reason is, you know, the issue whenever you have two different regions. So via BigQuery, you will have that issue. So that's it. And I'm going to use it as standard storage class. The reason is it's going to basically do lots of inserts, deletes, all those things. If I use some other storage class, it's going to incur better, higher cost. Here for data processing, standard is going to be a good choice. So click on create, done. Now better create a folder called as temp so that everything goes inside this. So copy this location, go to your. So the path, it should be something like this. They give a tooltip. Actually, the bad part is after you enter the details only, it gives you a tooltip. I don't know why. The help option. That's it, folks. So what we did, basically, we selected a endpoint where data flow endpoints are available. Data flow endpoints are regional, but when the job runs, right, it creates virtual machines, and they are going. Folks, you are able to hear me now? Thank you. Sincere apologies for that. Maybe I had some issue with the VPN there. So fine. So let me repeat it. So what we have done so far is basically selected a data flow in a specific region. It's the endpoints are regional, but when you actually create the job basically what's going to happen is going to create a virtual machine that is going to be a zonal resource. So let me just show you that. Is there any virtual machines currently in this project? No virtual machines in the current project. So that's the current stage. So using a popular template, a stream processing template, PubSub topic to BigQuery is what we are going to use. And that template expects two parameters or three parameters basically. One is the input, which is your PubSub topic. We have created brand new topic and we have created a table with a specific schema which we wanted to send, and basically a staging environment or a temporary storage is what we have done. So this is the stuff which is enough for us. Now, because it's the first time we are trying to do it, I don't want to complicate it much further. Uh, when we do IoT core concept, we will explore more on these configurations, folks, the advanced setup. So there is something like in the advanced setup where you can do auto scaling. You can mention how much stuffs you want to scale up and down, what is the kind of machine type you want to use for your uh, Apache Dataflow pipeline. You can mention that. Whether you want an external IP address or an internal IP address or a public IP address, you can mention it. You can do all those stuffs, but we will not do it now because it's the first time we are doing it. So let's keep it as everything as default, everything as default. So that's it. So if you mention these 3 points, you're all good. Now click on three parameters, you're all good. Now you can also get the equivalent of it. Gcloud Dataflow jobs run is the one which you're going to use if you want to run it from your command line. Now let me click on run job. When I run job, what's going to basically happen is it's going to provision a virtual machine behind the scene. So behind the scene, so if I see currently there's no virtual machine. We have to wait for a few minutes for, okay, something failed. Something failed. Okay, possibly, okay, good. There's an error here. So what is the error? Basically, it says network default is not available to access. So what could be this error, folks? Now you have done networking class, so you should be in a position to answer this. What does this error indicates? Awesome, awesome, folks. So Anil B and Mangesh got it correctly. So looks like our default VPC is deleted. Yes, we had deleted it, and we have to either add it or we have to give a different network. So connecting back to our VPC, see whether we have default VPC. I don't think so. We have default VPC. We have only two VPCs which are custom VPCs. So what I need is I'm going to use this one. I'm going to use this one where I can use subnetwork Singapore. So let me use this VPC. I will just use. Now the beauty is you don't need to fill this form again. You can clone this. Now there's one question which many times people ask me this. You see the job failed. This job failed because of the network, which is very clear that data flow requires a network because it relies on virtual machine. Virtual machine relies on network. It is very clear now. This entry cannot be deleted, folks. This is for audit purpose. That's the reason you cannot remove it. But if you don't like to see all failed jobs, you can turn on this one, this slider, which is going to show only the jobs which is currently running. Or you can put filters. You can put filters showing that what has been successful, something of that sort. But this entry cannot be deleted. Remember that. Now I'm going to click on this entry or the job which failed, and I'm not going to fill everything again. So I'm going to be a little smart here to click on clone button, where it's going to clone whatever I had included in the previous step. It comes up, everything comes back. So here we have to add basically the network details, this one. So I have to add this network details. So either you have to give the network or the subnetwork details. So I'm going to give the subnetwork details, and there's a pattern in which they usually expect. So everything is here in the help itself. So either you give a complete name like this, or use a short form. Either one is fine is what it indicates. I'm going to use the short form. This is the form which I have to give. So the region has to be basically Asia hyphen. So if you don't remember it, just go here, Asia. This is the one. This is the name of the region, and the name of the subnetwork is this one. This is the short form as per their help itself. I'm just going to add that. So I'm just going to add subnetwork. That's enough. That's enough. So you don't need to specify your network details, because subnetworks are, the names are going to be unique. It's going to pick it up. So with this, we should be able to do it. Let me see the rest command line equivalent of it. So it's going to be basically subnetwork is the details. So let me click on run job. Now see whether the job gets created. So I can click on the job. It is starting. Let's just wait for a minute here. If the job starts, the DAC should show up something like this. This is the DAC. And if the DAC starts up, I should see a virtual machine getting provisioned. So let me just refresh it here. Not yet there. So let's just wait for a minute. So it is not there. Under your topic, PubSub topic, subscription will not be there. So this is all an indication that the job, now it came up. A new subscription came up of type pull. This was created by your Dataflow job. And if I go to my virtual machine, refresh it, you should also see a couple of entries. The reason is the default is going to be two worker nodes. Two worker nodes got provision. So, and you should see the word PubSub Dataflow. This was your job, your name, some alphanumeric characters ending with harness some name. So it's in Singapore. Any zone it is going to work basically, and you have an external IP address. We are not a great fan of external IP address. When we do something in our IoT core demo, we'll make sure we run our Dataflow job with in a private mode. So this virtual machine does not need to have access to internet. So we'll try to do that part. And if I do this one, recommendation, not recommendation, in use, it should have shown that. Does not show you that. Dataflow job at the end is nothing but a job which runs on basically a virtual machine. And to get the further details, you also understand that this is nothing but managed instance group. Managed instance group. So if I go to my template, there's going to be a template created by it automatically. So this is the template which got created now on 2nd of May. And if I go to my, if I look into the template, for example, now these are all connected. These are all connected. That's the reason. So if I look into the template, it shows by default, if it's any stream processing, It's going to take 4 vCPU, 15 GB of RAM. So more RAM is required for streaming jobs. So that's the reason it gives you that. And any other information which you can capture? No. If I go to my instance groups, we know instance group can be zonal or can be regional. You can have the multi-region, you can make it. So this is the instance group which is there. Click on this and you will come to know the configuration which you have done. If I click on edit, so what you have done is basically a zone, not a multi-zone. So by default, whenever you use any templates and do it, it's going to be a zonal resource. And if you remember, if I just go back to my MIG, create an instance group, I can create it in a single zone or a multi-zone. We had done our demo in multi-zone, but the data flow which gets created, the job is always a single zone, which is very clear. It is a managed instance group. It is in one single zone. By clicking on the details also you'll come to know that. So it is basically one zone, and that is very clearly mentioned even in your, it is single zone. In that zone only it's going to create all the virtual machines. So it's not a multi-zone. So basically I can have this form filled in two different fashions. Data flow endpoints are going to be regional. Data flow jobs which are going to run, these are going to be by default zonal, because it's going to be on a virtual machine. So that's what it indicates. Now going back to my job, more about the job. So now you saw the backend part. What is that? All those things. Now this is how the DAC looks like. The output, when you selected the job, right, the template, it showed you a DAC. The same thing is what you are seeing here also. Read PubSub topic, convert the JSON format into tabular form, everything is going to show it here. And the type of job, it indicates it's streaming, it is currently running, and what is the Apache Beam pipeline version it is using. So Java, it's not, the templates usually use Java because it's little stable. It shows the job region is this, worker locations are in Singapore C zone, current number of worker nodes are 2. So it shows you all those details currently. Now if you go and look into your BigQuery, will you see any data, folks? If I run this job, if I do a preview, query my table, how many rows would you expect to see? How many rows would you expect to see, folks, in my table? It's going to be one. It's going to be one because you have not even sent any data. So you have to stream the data, only then it's going to come. So if you don't stream it, nothing is going to happen. Your data flow is going to simply be running idle, and you will be charged. You'll be charged for 2 instances. Basically, you could have made it as one. So it's going to be basically the cost of your virtual machine is going to be your cost of your data flow job. So streaming job will never stop. Batch job is going to stop once the data is over, it's going to stop, but streaming job is going to keep on running unless you go and explicitly stop it. So currently there's no data sent to my PubSub, so which has not reached my data flow, and data flow has not done any processing because you have to send the data. So let me send the data now. First I'm going to send the data manually, 1 or 2 records. I'm going to send 1 or 2 records manually, and you may see a warning message that is nothing much but some quota issues. insufficient quota. So we should not have that error. This thing, it's a warning message, so I can ignore that. So the job is set up. So till here, hope things are clear, folks. Till here, the things are clear. The job is running, but you have not sent any data. You have not sent any data. So what we will do is, I'll just send a couple of data, and we will see the data getting inserted into BigQuery, transformed and inserted. And then we will use that program, the Python program, to send 20 or 30 such records and see how it gets inserted. Okay. So what I will do is go to my PubSub, and I'm going to click on my PubSub and publish a message. Publish a message. And what should be the format of the message? Do I have it? I don't have it. Okay, let me just open the code. BigQuery virtual machines would be here. Good. So let me just open up player ID. So if I just cat PubSub, so it has to be player ID. This is the code. So what I'm going to do basically is, so I'm going to send basically player ID 100, score 50, name user 1. So this is my JSON format. Let me see whether the syntax is correct. Validate my JSON. Okay, this is a valid JSON. Good. So now what I will do is only insert it manually, like what we did yesterday. I'm just going to do the same thing just to check once things are all fine. Publish. Now it is published. Now you can track whether the data has reached PubSub or not. So reached PubSub, then you should see this value, folks. Here I'm in my data flow. I have added one message, so it should show one element added. If I wait for a couple of minutes here, it's going to show one element added. Currently it shows hyphen. Now it got auto refresh, so it's a frame, so it gets auto refresh. So one element added. Now if I come to my next DAC, it shows that element was processed. So good. Now if I go to my successful records, it shows even there it has been done. So meaning it indicates the data has been inserted successfully into my BigQuery. So to verify it, go ahead and run this query. You should be able to see a second record, which very clearly indicates my streaming pipeline is working. So we just tested it and it is working. And if I just go back to my gaming data, now click on details, you will see some difference. This is what Vivek was asking last week about stream processing. So looking into your screenshot and look it now, you will see a difference. What is the difference which you see is basically this entry, folks. This entry. So it has a capability of doing streaming insert. So it says the data, the one row which I one player information which I sent in JSON format is not even persisted on my storage. It is in a buffer. It's in a buffer, and one row has been done is what it indicates. Now when it's going to flush, it's going to totally depend when it's going to flush. So there's no specific timelines. So you can search it in the net, you can search in very good number of forums, nowhere the details is mentioned. So when it's going to flush, nobody knows, but it's going to flush. But we should not be worried about whether it's going to, when it's going to flush it on the storage. The reason is you don't need to worry there, because at the end what you want to know, if I just query it, if I query this, I should know there are 2 rows inserted. I should get that. That is my endpoint. So I don't care whether the data is on the storage, BigQuery native storage form, or is it in the streaming buffer. I don't care. But when I run a query like this, directly I get it. Or when I run via a BI tool, I get this. So for me, I'm reading live data and also data which is already there in the system. So that's the real cool feature, which you may not get it in any other product, folks. Querying streaming buffer and querying also the data which is stored on the disk, which is really a cool feature. So let me just stop here. Is the concept clear? So there are 2 types of data currently stored. One is the actual data which you did bulk upload, 1 row, and there is 1 row which you inserted, and because the data flow is using a streaming buffer option, it has inserted the data in a streaming buffer, which is 1 row there. Now when I query it, I don't see any difference. So which is very clear. You can use a BI tool connected to BigQuery, and it can show you live data. As data is getting inserted, you should be able to see it. So is this part clear, folks? So if it's clear, what I'm going to do is I'm going to run that script. I'm going to run that script, which is going to generate 20 such records. It's going to insert it. Immediately, I'll come and query it, and I should see totally the number of records. One, already 2 records. If I run the report, or if I run the script for 20 times or 30 times, totally 32 records is what you should see once the data is inserted. Basically, it will not persist here. It is going to take some time. Basically, it's going to be in the buffer. It's going to be in the buffer for a longer time. So maybe by end of our class, we can just give a check whether it's going to be flushed onto the disk or not, or it's going to take time. Now what I will do is trying to run the code in a more like a simulator, more like a simulator. Let me see whether I have done all the necessary changes. Let me run it for 2 times, just for two times. Then we will do it for 30 times. So that you will see the changes happening. So everything looks fine. Now if I do Python, done. Go to your data flow, click on the first DAC. This line should become now 3 because 2 more entries have been sent, or 2 more elements have been sent. Let's just keep an eye on this part. Yes, so 3 data. Now when I see my message converted to tabular form, 3 successfully also written 3, meaning my data has been inserted. So if I refresh the screen, or let me open a new screen, just minimize this storage. Yeah, I'll use this one, folks. I'll go to BigQuery. I'm using a different tab so that I don't need to refresh it. So if I go to my gaming data, you see 3 rows in the buffer. But if you do the preview usually shows what is there in your storage. What's there in your storage? The preview has that limitation. So let me try refreshing it and see whether it shows. Usually preview will not show, is my understanding. The preview will not show it. But if you want to know the complete data, you have to query it. Preview only reads from the storage. What is there? It cannot read it from your streaming buffer. So if you were to get it, basically query it. Query it is going to show totally 4 rows. So 4 rows. So far, if it's clear, I'm going to just run the command once more for 20 times. So totally, I should have 24 records inserted. So oh, sure. Okay, I ran it. So it's going to be 26, folks. So I should have edited it. So let me make it as 20. 20 people are playing and they are sending some data and you wanted to see how it works. So let me run it now. So totally 26 should come because I just ran it once again. So if you see here, 5 records are already there. 5 records, 5 records are inserted via here. 1 record manually inserted, totally 6 records. Now 20 more, so it's going to be 26 is what it should show. So hit enter. So 20 such records have been sent. Now let's keep an eye on this. So it should become 25 now. So actually I have to keep it here. Yeah, 25. 25 records processed. 25 records came here also. Good. And it should have been inserted now. So if I just go to my streaming buffer and see, it's not yet there. Let me just refresh it. Details still not there. Okay, it's still not inserted. It's only showing 12, 11 records. Let me just query it once to check how many records I get. So if I run it, 26. I see 26 fully, all the 26 records, but my streaming buffer, okay, it shows, it is now updated. So good. So this is your streaming inserts which you use in BigQuery, and as a BI tool or as an analyst, you don't need to much worry about it, whether it is from a buffer or from a actual native storage. You will not have any difference. So this is what usually called as BigQuery can handle streaming data. This is the actual meaning which I have showed you in the live thing. So Vivek, which you asked last week, hope that is answered now. So this is how it handles basically. Okay, so we'll just stop it here. I'll keep the job running. We'll take a 10 minutes break. Once we come back, we'll see a few more stuffs. So we had a nice format. It started working very beautifully. But what if some formats gets modified or you send a wrong data? How this template works, error handling, how it does the error handling, I wanted to show you that. Then we can move on to the next part. Okay, so let me just stop here.
This conference will now be recorded.
So before the break, we saw how the stuffs work. If the pattern or the format in which BigQuery is expecting, if you send it, it's going to be inserted into your BigQuery table, is what we saw. If I just refresh the screen also once, you will see we spent 2 minutes, like we left it for 10 minutes, right? So the data is not going to be flushed. It's going to take time to flush. So but apart from the tables which you have created, you don't have any other table. Now that's the current stage. What I'm going to do is I'm going to send a data which is totally not in the format which is expected. So I'm going to send it as player 2 and something like this. Player 2, we don't have a table called as player 2. Now when it is trying to parse it and trying to insert, it's going to show player ID 2 not found, so it's not going to insert it. But you want to handle such errors, right? Things which are not in that format, what's going to happen? So in that case, basically what it's going to do is it's going to create an error table. The template does that. The Dataflow template does that. It has that error handling capability, and it creates an error table and inserts it there. So that way you will come to know any errors and you can fix it. So the reason for showing this part of the demo is you can share this kind of an information to the data engineer. If they are very good in writing Python code or Java code, but they don't know how to do the error handling with respect to GCP. They may do error handling in a log file. We don't want that, but you can give a guidance like that. Any errors, put it into an error table in BigQuery so that I will have one place to find everything. I don't want to see the error in the logs. I don't want to see the successful stuff in the table. So I don't want that kind of a stuff. If you want everything in one single place like BigQuery, this won't be a good choice. So let me publish this. Now, if I come to my data pipeline, this 25 should become 26 because we have sent one record. And this is a frame, folks. That's the reason it keeps refreshing automatically. I don't need to do anything. It's a HTML frame, iframe, sorry, iframe. So 26, it became 26. Did it convert? Yes, it converted it. Now, if you click into the successful writes, it shows, but failed records, it's going to show as 1. This is a failed record because the format was not good. How do I see it? Go to your BigQuery. If I refresh it, now you will see one more table called as gaming underscore data underscore error record, something of that sort. So where you will see that one row inserted there. So if I just refresh it, you see this, folks? You see this record? So it's going to be the table name underscore error records. So basically it's going to have a content something like this. So this is the payload, and why it failed, it also gives you that a message. The message is message to sorry, player 2, no such field, invalid, I cannot insert it. So this is how it shows. So the whole concept here is how do you do error handling with only BigQuery itself. So Dataflow and BigQuery, you should be able to handle your errors and store it also for long term fixing and all. You can see, okay, how do I do this part kind of a stuff. So that's going to be a good handy option. Now, one last thing I wanted to show you, then we'll go ahead with the next part. The job will never stop, folks. This job will never stop because it's a streaming job. So clear the selection. Since it's a streaming job, it's going to run always like this. Now, you may make a mistake like this. Because it is serverless, I'm going to leave it like this. The serverless feature comes only here when you put a huge load. From 2, it can become 3, 3 to 4. Auto scaling is going to work. So if there's no load, it may scale down to 1. But that one instance is going to always keep running. So you have to explicitly go and stop it. Otherwise, you will be paying a charge for N1 standard 4, which is 4 vCPU, 15 GB of RAM. So to avoid that, basically you have to stop it. So click on stop. You get two options: stopping the job, cancel, meaning immediately shut the door. I don't want to process anything further. Immediately do it. Drain is a graceful shutdown or a graceful stop, where if there's anything in the pipeline, it's going to process it, but anything new coming will not be processed. So two different options. So before I click on I don't have anything in the pipeline, I'm going to do cancel. Before I do that, what's going to happen, I'm going to show you. When I do this one, right, first and the foremost thing, what's going to happen is these two virtual machines are going to be automatically removed because you did not create it. This got created via the data flow. And once the data flow job stops, it should automatically get deprovisioned. That is one thing which is going to happen. The second thing which is going to happen is your PubSub subscription, which was created only for this purpose, is going to be automatically removed. So these are two things which is going to happen. So let me go ahead and cancel the job. Job canceled. Now if I come to my virtual machine, refresh it. Okay, one is already gone. The other one, maybe it auto scaled to 1 because of not much load. So now it is deprovisioning. It is getting, it is going to go to stop and then get removed. Once it happens, the subscription also is going to go off. It's going to go off. So let's just wait for that. No more VMs. Then if I come to my subscription, the subscription should also be removed. If I just wait for a minute. still there. It's going to take time, I guess. It should have been deleted. Yes, it is deleted. So now the PubSub topic comes back to the normal state where you, without any subscription, you are going to get the same warning message. Back to square one where you started, and you see how much data came, all those details. It shows you that. So this is basically your stream processing stuff where it can do error handling, all those things. Now, if you go to your BigQuery, the streaming buffer is going to be still there. The streaming buffer is going to be still there. It's going to take time. Usually I have seen it is like 2 hours or 3 hours it takes. Afterwards, it's going to flush it to the actual disk. So we have to wait for that. We have to wait for it. There's no official answer for this. What is the time? 1 hour, 2 hours or something. But what I have observed is 2 or 3 hours it takes to flush the stuff. And they give a very diplomatic answer. It depends on the amount of data. So basically that's how they mention it. So that's something on your stream processing pipeline, which I wanted to show you folks. So we will do one more demo where along with PubSub, we are going to have one more component called as IoT Core, PubSub, Dataflow, BigQuery. So where you will see a complete IoT related use case. Now what we saw was a streaming use case. Yes, IoT and this both are going to be streaming only. But here we use a simulator to generate it. In the IoT use case, we will see as if like a device is sending data, a simulated device which sends data. How it works, we will see that. There we will try to optimize our data flow job. Using internal IP address, we will use service account, specific service account. Maybe you can do that exploration, and next week when we come back, you may give me an information from a data flow job at the end runs on a virtual machine. If you don't mention anything, it's going to be using default service account. Now when we do the IoT core demo, right, I'll explain you what is IoT core as we go. A virtual machine trying to insert some information into BigQuery. What kind of roles you should have, you have to tell me at that time. So maybe you can go do an exploration. So we are not going to use default service account. We are not going to use external IP address. So we are going to do some fine tuning there. So when we do the second time, similar demo with IoT core. Okay. So with that, the data flow stuff comes to a end, and this architecture is a very standard architecture which can handle where basically your PubSub, Dataflow, BigQuery. So the main part here is Dataflow. How you can use Dataflow in multiple use cases. So very simple. PubSub, Dataflow, BigQuery, PubSub, Dataflow, Bigtable, PubSub, Dataflow, Spanner, something of that sort. So with data flow being in the center, what are the things which you can achieve? This architecture can serve multiple use cases. For example, if I take, say, for example, fraud detection, this architecture can help. So what I can do, basically assume it's a credit card. A credit card is issued in country A. For 6 months, the card has been swiped in country A only. All of a sudden, this credit card is swiped in country B. Now, should the transaction be processed or not in your point of sales, POS, or not, should be decided based on some kind of a machine learning concept. So how will I do it? I can do this here with the help of data flow, PubSub, all those things. How? Assume I have a POS here. Oh, sorry. So point of sales, I'm in country B. I swipe this credit card. Now that message first goes to PubSub. PubSub can stream very easily the data. It comes to your data flow. Data flow does any transformation required, sends it to BigQuery. Sends it to BigQuery. Now I am going to run some machine learning stuff where I'm going to see the history. Because 6 months I had used this credit card in country A, so that all those information is going to be there. The historical records are going to be there in BigQuery. I have a component in GCP which we are going to talk more in our module 7, maybe next Sunday if I'm not wrong. So which is going to get that understanding, okay, this is the pattern. Is this a fraudulent transaction or not? It can do that machine learning stuff and send a message back to the point of sale whether to process the transaction, approve the transaction, or decline it. So I can do this kind of a stuff very easily with this combination, with Dataflow being the middle component. So same architecture can serve basically for fraud detection. Now I can use the same architecture, almost same, for say for example some kind of IoT device. So now I have an IoT device, sends the data to a component called as IoT core, which we have not discussed yet. So from IoT core, it comes to PubSub, PubSub to BigQuery, Google Cloud Dataflow. Then it's not going to go to BigQuery. It will go to Bigtable. The reason is I have a requirement of having very low latency requirement. And we know Bigtable can also handle streaming data. So the data comes to Bigtable. Now you do what you want based on the next step. So data is in Bigtable. You can do anything with lowest latency, do it. The same architecture with Dataflow being the middle component can be used for n number of use cases, for IoT analytics, for fraud detections, lots of stuff. So a standard architecture, you can use it. Now, a couple of days back, I saw a post from Google. I guess you should have also seen it if you're following it. Very nice post. Let me just show you that. Hope I have bookmarked it. Yeah, this one, folks. I'll just put it in the chat. I recently added this because this information was even shared a couple of days back only. What is this is basically various sample architectures are going to be there. Use case, say for example, building a telecom network anomaly detection using k-means clustering. So some machine learning, all those things. So the products which is going to be used, BigQuery, DLP, there are some products which we have not explored yet. Dataflow, PubSub, storage, BigQuery is what we know. DLP, cloud build to some extent we know. What is DLP? We don't know. So, and it's going to show a reference link, a code, some video. So like that for n number of use cases, they have created a one single pager, which is really awesome. I would strongly refer you to use this for your real implementation. So it's going to be like one-stop shop for doing most of your stuffs here. So leverage it. There's going to be some sample code, all those things, which is really a good one. So thought of sharing it. Use this. And if you are interested in looking into the data flow template code, if the developer asks, can I get the code where I can modify it, you can go to just search for Dataflow templates. You get the template called as Google provided templates. So all the templates which you saw is going to be there. The one which we used was this one. If I click on it, it gives me the entire details. How should you send these details, all those things. You should send a PubSub topic like this, key value pair. That is what we did. You send it like that. You give your input output specification table, those details. That's it. And how to do it, the same thing. I just follow the documentation, nothing else. So, and this is the actual Java code. If the developer wants to extend this, if he wants to extend it, he can do it. The actual link goes to a GitHub page to do it. So if they want, you can ask them to refer to this basically. Okay, so that is something on Dataflow, one kind of a ETL tool which Google provides, and it is totally serverless. But the only drawback I would say is somebody should be well versed with Java or Python, and good exposure on how to use this Apache Beam pipeline code. So you need to have hire a person who has the skill set. Uh, Only then it's going to be really helpful. And because you're going to write a code, you can do whatever you want. Any kind of transformation you want, you can do it because you can write a code. So that's the pro and disadvantage of it. Now we will see one more ETL tool using which you can do something very similar: streaming analytics, batch processing, all those things using the traditional stuff, which is going to be our Hadoop and Spark jobs. So if it's a streaming job, I'm going to use Spark job. If it's a batch job, I'm going to use Hadoop. So how do I do that? It fits in a traditional way. So it's streaming and batch is not something new to many organizations. They have been doing it in on-premise itself. Now, if you are working with a customer of this sort who already have a Hadoop job, very stable, running for ages, uh, very stably running, but they now want to move it to cloud, lift and shift, or they may have a streaming job, the enterprise Lambda architecture which we saw, they may have a setup similar to that. So they want to do a lift and shift. Basically what they want is a Hadoop ecosystem in cloud. So to provide them that option, Google gives you an option called as DataProc, which is nothing but a managed Spark and Hadoop cluster. You get a Hadoop cluster which can support Hadoop jobs like pig statement, hive jobs, uh, PySpark jobs, Spark SQL jobs, everything they've provided. So you just provision a Hadoop cluster called as DataProc in GCP and do a lift and shift. So the difference, if you see between your Dataflow and DataProc, both can do the kind of job which you are expecting, a kind of data transformation, ETL, it can do. But the difference is one is very modern, the other one is little traditional. So Dataflow is going to be more modern. So I usually prefer to use Dataflow if it's a greenfield application. So no existing Hadoop jobs, Spark jobs. For a longer run, for future proof, we will use basically Dataflow because it can handle in the same code base both batch and streaming, right? But if it's a Hadoop job or a Spark job, it is specifically built for a specific use case. Spark jobs are usually for streaming, Hadoop jobs are usually for batch processing. So if it's traditional or brownfield, I use DataProc. So that's the difference: when to use DataProc, when to use Dataflow. So you get an equivalent of this in other cloud also, Elastic Map Reduce, EMR. In Azure, it is going to be called as your HD Insights, which is along again with some uh, tie-ups or close relationship with Hortonworks and Cloudera, all those things, basically. So what is DataProc? It is nothing but a managed Hadoop and Spark cluster. So uh, I can just give my own example here. So before exploring Hadoop concepts, like working on, I have worked only very few times on Hadoop, only for POCs, and that too for POCs. To set up a Hadoop cluster on the laptop, it used to be a pain when it was like 4 or 5 years back. So it was a pain to do, always set up a Hadoop cluster. But with the cloud coming very super easy, you can just go click on the Hadoop, the DataProc page, and it's going to create a Hadoop cluster based on your requirement. How many worker nodes you want, what is the number of masters you want. You just provision it and things gets provisioned, and you load your existing job, and it's going to work. And Hadoop by default is a fault tolerant system. So meaning if you have two worker nodes or four worker nodes, for example, one worker node goes down, no problem. The three worker nodes continues to work. They're going to share the load and they are going to work. And if a new node comes, again, it's going to be distributed. So it's by default fault tolerant system. So if it's a fault tolerant system, the concept which we learned in our compute engine, preemptible VM, PVM, could be used. Why that could be helpful? For example, if you have a Hadoop job or a Spark job, assume a Hadoop job. Hadoop job, it takes 20 hours. With what specification? One master, and basically 2 worker nodes. This is going to take 20 hours. Now, what I'm going to do is, because I'm in GCP, I can use PVM, preemptible virtual machine, which can be taken by Google at any point of time by just giving a 30 seconds notice. So what I'm going to do is, I'm going to add 2 more PVMs. Basically, what is going to happen? I have 4 nodes. Maximum 4 nodes is going to be running. Now, the implication of this is going to be the quickest, assuming these 2 PVMs are going to be there for minimum 10 hours. My job is going to be finished in 10 hours because 2 worker nodes can finish it in 20 hours. 4 worker nodes can finish it in 10 hours, assuming the job is not taken. The PVMs are not taken back, or maximum immediately you provision a PVM, immediately it is taken back by Google. No problem. I have 2 worker nodes, regular worker nodes. It's going to take 20 hours. Now we can give an SLA to your customer if there's a job. Uh, if I use preemptible, so from this time to this time, you can give that time period. 10 hours is the quickest you can get. Maximum is going to be 20 hours. So the advantage of preemptible VM with your Hadoop is going to be quick. You are going to run in 10 hours. You are going to finish it. So quickness or quick, that is one thing, and it's also going to be cost effective. The reason is running a server for 20 hours is going to definitely cost you, but running a server at 10 hours is going to be lesser, and also you are going to use 2 more additional VMs in this case, which is going to be provided at 80% discount, up to 80% discount. So definitely it's going to be cost effective if you use preemptible VM. Now you see the connectivity between the stuffs which we learned. Dataflow also relies on MIG VMs. DataProc also relies on VMs. So, and that's the reason we were spending good amount of time in our fundamental class. So that's basically your Hadoop stuff, folks. Nothing much to talk about here. Basically, you prefer to use DataProc if it's a traditional lift and shift kind of a workload. If they say I want to have an ETL job, you can run it using DataProc. You can run it using Dataflow. So far, what we know, there are a few more other products in the pipeline. We'll talk about that. So 2 options are there. Now, if you have 2 options, you should have a tiebreaker. The tiebreaker is, ask the question, is it running on a Hadoop cluster, or is it a Spark? It's running on a Spark cluster. It's a Spark job. If they say no, we want to build something totally new, or if they say it is running on Informatica or kind of stuffs, you have to run it on a virtual machine. If they say it is on a Hadoop job, you have to run it on DataProc. If they say no, we don't have anything, we want something which is more serverless, zero ops kind of a stuff, then go with your data flow. Go with your data flow. And the current types of jobs which it supports are Hadoop, which is your MapReduce job written in Java, Spark written in R language, Scala language, SQL, or in Python, Pig, which is going to be written in Java, and Hive, which is going to be more like your querying, a SQL query, because not everybody will be well versed with Java, so they may be comfortable with SQL. So on your Hadoop distributed file system, you can use Hive to query it. So that is the stuff with your DataProc. What we'll do is we'll quickly do a very simple demonstration on DataProc, how you can provision a DataProc cluster and access it. So, and people who have worked on Hadoop, I can also show you some information how your management stuffs looks like. There are a couple of ports. If I open it up, you should be able to see those distributed file system and your management console, all those things. We'll also do that. Okay. So, and we'll try to create a preemptible virtual machine also for our demonstration purpose. So if I go to let me close all the stuffs, folks. It's going to take space. So if I go to my home screen, and I'm going to basically use Under big data, I'm going to use something called as DataProc. So pin it, go use your DataProc. Again, DataProc APIs are not going to be enabled, so you have to enable it. So it's going to redirect to me to that screen. Let's wait for that. It says DataProc APIs are not enabled. First, enable it. What is DataProc? Managed Hadoop based cluster and runs your job on Google Cloud. So let me enable this. So for people who have not worked on Hadoop, it's going to be a master slave or a master worker node kind of an architecture. The whole reason why Hadoop became so popular was you can run things on a commodity hardware. So you don't need to have a very powerful one single machine and you do everything there. So on a very commodity based hardware, something like 2 vCPUs, 4 GB of RAM, that's enough. But I have multiple such things and easily split my work, do it, and then aggregate it and show it as a report. So that is where Hadoop really started shining. So now to set it up, it's going to be a little difficult. Now people have various options, scripts, all those things. But in the beginning days, it was a little difficult. I have myself seen my organization doing a consulting work for setting up the Hadoop cluster. Only Hadoop cluster, nothing else. The hardware is going to be there. The cluster is going to be set up and they will run a small word count example. And they used to charge or the duration was 5 days for that. So that is the kind of stuff. Now I can provision a cluster in less than 5 minutes in GCP. So that is the way we have uh, changed by coming to cloud. So let me click on create a cluster. Create a cluster. Now this behind the scene literally uses virtual machines, folks. Literally uses virtual machine, not even basically managed instance group. It just uses plain virtual machines. If you say master, I want one master, two worker nodes, totally you're going to have three virtual machines. So if I just go to my virtual machine screen, you'll see virtual machines once it has been provisioned. So it's basically a virtual machine, nothing else. So let me give a name, cluster batch 6. This is a zonal resource. DataProc is a zonal resource because virtual machines are zonal. So let me select Singapore and I will mention a zone. So it's a zonal resource very clearly. So without forgetting it, I'll make sure I fill this form right away. Otherwise I'll forget it. So DataProc, Cloud DataProc is basically a zonal resource. I'll fill the node later. So it's basically a zonal resource. So when it comes to the type of clusters, this could be important. This could be even asked in your exam. Only these three options could be a possible question. So let's spend some time on this. The different types of clusters which you get are first option, single node. This is usually called as pseudo mode, which is really good for learning purpose and for some proof of concepts. What does this mean? Basically is only one node, folks. One node is nothing but one virtual machine. You'll have only master. The master does everything. One man army. That's it. So this is a single mode, pseudo mode, usually used for learning purpose and proof of concept. The second thing which you get is basically a standard mode or standard cluster type where you get one master, minimum two worker nodes. More than two, you can have it, but only one master in one master and n number of worker nodes, all in the same zone. Now, what if the zone goes down? You'll have issues. You'll have issues. That's where if you want to have a production high availability, you are going to have basically 3 masters across all the 3 zones in your in the region which you select, and you can have n number of worker nodes. So if you want high availability, you go with HA mode of your cluster type. If it's like a development environment, one master is enough, means you can go with standard mode. If it's for learning purpose, just go with the pseudo mode or single node mode. So this could be a possible question which you may get. So we'll just make a note of this by uh, really sorry folks, I don't know what's happening to my internet, sorry. Got disconnected again. So what we'll do is we'll just add this line. So if you want HA mode, basically you have to use this one. So HA DataProc. I guess you are able to hear me, right, folks? Yes. Okay, thank you. DataProc in HA mode for production. For production is what you use. For DataProc in standard mode for dev environment or non-critical environments, and DataProc in pseudo mode, usually they call it as pseudo, or single node for self-learning or POCs, for learning or POCs. So that's what is an important, this could be an important one. So let's go with one master minimum and 2 worker nodes. Minimum is 2 worker nodes. So you can also do auto scaling with your Hadoop, meaning if the workload is going to be too much, 2 nodes are not going to do that. So you need more. You can create a policy. You can create a policy if you want auto scaling policy, and you can apply it. So that is going to be applied only for standard mode or for auto scaling. If you do it in a single node, because by default you mentioned itself it's only single node, there's no auto scaling option going to happen. So let me go with standard, one master, at least minimum 2 worker nodes. And this is the important piece here, which you need to get these details from the customer. If they are going to be a lift and shift migration, what is the Hadoop version they are using? So if you see the change, these are the options which you get. I heard from one of the person where in an interview call they asked what is the version you have to use. to this level of information they were asking in an interview code. So if in the on-premise they are using some version, say for example Hadoop 2.9, then you have to use this version basically. Or if they are using the latest one, latest and the greatest one, so they can use on CentOS, you can get it. So this is the latest one. This is the latest one. So getting the actual version of Hadoop from 1.x, 2.x to now 3.x, you have different versions of Hadoop. What is the version? Get that. If it is not listed, no problem. You have to create a custom image and use that. So your custom image concept is going to come into picture here. So you have options to use older versions also. And if you say, I don't want on Debian, I don't want it on CentOS, you want it on Red Hat, that's what you are doing it in on-prem. Again, switch back to your custom image. So go create a Red Hat instance, install your Hadoop stuffs, create a custom image of it, then browse it, and you should be able to get it. So our learnings in our virtual machine gets applied in our big data concepts. So let me use the latest one, Hadoop 3.2 and Spark 3.1 version. That's what I'm going to use. And there are going to be other components which you can turn on. So I have seen in organizations, they create Hadoop cluster and on the Hadoop, because it's going to be distributed, right? They run on top of it some tools like Notebook. Notebook is a very popular one where you can do interactively run codes. So, or you can have something like few stuffs like, say for example, running a search engine like Solar, having Docker running on it. So you have these optional components which you can run on top of your Hadoop. Because it's distributed, you can leverage it. So you can use a Jupyter Python notebook so that you can leverage the distributed file system there. So that's the option which you get. So basically what we have selected a reach, a zone, a zone. Standard type is what we wanted, and we are using the latest version. Now you need to mention the details about your nodes, each node, what should be the configuration you wanted it to use. So there you get it in the second section where it is the master node. Now it's not really good to compare Kubernetes with DataProc or Hadoop, because these are two different purposes actually. So, but in Kubernetes, what the only reason why I'm bringing Kubernetes back here is, in Kubernetes, if you remember, the master was fully managed by Google. We were not even being able to see the master node. But in your Hadoop cluster, you can see the master. You can see what configuration you want to give to the master. You can do everything. You can do everything here. So minimum, they have made it so difficult. So I'm going to use N1 standard 2. So I can configure it. I can say how much storage I want, all those things. What kind of disk you want, you can mention everything. So you have full control. You can also have GPUs also added. So you have full control here to your master. Once you have mentioned you want the master of this configuration, then is where you mention your worker nodes. How many worker nodes you need to have? Minimum 2. If I mention it as 1, it's going to throw me an error saying that the number of nodes has to be 2 only for redundancy purpose. If one node goes down, you have another node still continue to work, basically for that purpose. So minimum 2 nodes is what you need to have. You can also mention what is the configuration of those nodes. So since I'm running on a free trial account, so it's going to have some quota limit. So quota limit is, in one region I cannot run more than 8 vCPUs. Already 2 vCPUs used by my master, so I'm left with only 6 vCPU. So let me just be little smaller size. I'll configure it with a smaller size, N1 standard 1. So totally it's going to be 6 vCPUs are going to be totally used. 6 vCPUs are going to be totally used so far. And I can have a lesser storage. If I give 500, right folks, I may exceed my persistent disk quota. So make it as 30 GB. That should be good enough. That's it. So that's your worker nodes, two worker nodes. Now we talked about preemptible virtual machine, right? Where can I configure it? Under secondary worker node. The primary worker nodes are always regular virtual machines. Preemptible virtual machines are going to be your secondary worker nodes. So if I just expand it, you can tell how many virtual machines you want. I cannot tell more than one, only because of my quota issue, because already 6 VCPs are already configured. So I have to mention one preemptible VM only I want, and I will also mention I want minimum 30 GB, and it is going to be of type standard persistent disk. That's it, folks. So there is a new option to use sole tenancy also. You can turn on shielded VMs, all those features which you want. So totally, so you can mention all those details. So totally what we have done is one master, three worker nodes, of which one is a preemptible virtual machine. So totally, once we create the instance, we should be able to see 4 virtual machines in our compute engine screen. That's what we should see. And if you want to optimize your cluster further to use a specific network or anything, since we don't have a default network, we have to mention the specific network. Otherwise, it's going to throw the same error. You can add some tags, network tags, all those things if you want. I'm going to add one network tag called as Hadoop access. Why? Because I wanted to turn on certain firewall rules where I can access certain Hadoop ecosystem, basically management, Hadoop file systems, all those things, distributed file systems. And you can also run all your Hadoop cluster. Basically, it's virtual machine. So if you want to have internal IP only, you can leverage it. You can leverage it. So that's something which you can use. So those are the stuffs. There are a few beta stuffs. No need to talk much about that. The last option, which is one of my favorite option, is that there or not there? 1 minute. There's one cool feature. Yeah, under my customized option, we have used our own network, VPC. We have added a network tag also. We will use this to create firewall rule one more time. Uh, you have other few options which you can give. One of the important thing which I really like with this option is scheduled delete. Now, I have seen in on-premise folks, people will never delete a Hadoop cluster. Even though there's no work, they will not delete the Hadoop cluster because they would have done implement like provision this with a great difficulty. If there is no job for the Hadoop cluster, even though it is running on an infrastructure, they will leave it remain like that, or they will hunt for jobs, reach out to various sub-business unit in the organization, and I ask whether there's any Hadoop job which we can run, because we have an infra provision, so we don't want to run, leave it being there idly there. So they will usually do that. But when it comes to cloud, right, you don't need to do anything. So if your job runs only for 10 hours, no problem. What you can do is you can mention a setting like delete my cluster after 10 hours, or maybe give some buffer 11 hours. After 11 hours, if the cluster is idle, delete it. I don't need it. Tomorrow again, when I start it, I will on the fly, I'm going to create a Hadoop cluster. Maybe 15 minutes before, I'm just going to start it, and I can, once I finish it, I delete it after 11 hours. So I can use this very, very effectively. So this is going to save me the cost. And what I'm going to do is I'm going to do it in few minutes. So I'll make it as around 30 minutes. Hope we have 30 minutes. Yes. So I'm going to make delete the cluster if there is no job running on this and the cluster is idle for 30 minutes, delete it completely is what I'm going to say. So by doing this, what is going to happen? I don't need to go worry about whether the job is not there, should I be incurred or not. This is a cool feature. This is a very cool feature. The next thing is you can mention your storage bucket for your staging purpose. If you don't mention it, it's going to create one. It's going to create one for you, basically. So this is an important one to save some cost. So what we have done, we have created a 3-node Hadoop cluster, of which one is a preemptible virtual machine. We have configured the machine types for it, and we have also made sure the cluster is going to be deleted automatically. I don't need to do anything after 30 minutes if there is no work for the cluster, and some security stuffs which you can turn on as usual. The encryption part, the access. What is the access you want? This is going to be basically controlled by your service account. Should you get access to the full access scope? It is talking about this access scope. So if you want to give it, because uh, there was no place where it was saying the service account details. uh, there should be an option. Actually, it does not show the service account option in the command line, what service account to use. Make sure, and in the command line you get that option. In the UI you don't get this option, but via your, for your service account, you want to give full access, you can turn on this part. So the command line equivalent is going to be something like gcloud dataproc clusters create with all the details. And one of the important stuff is this one, maximum idle time. So 30 minutes afterwards, delete the cluster automatically. So let me just click on close and click on create now. The cluster is going to take roughly around, it's 5 minutes or so. Maximum it's going to take 5 minutes to have the cluster ready. It shows 3 node. So, and we know because virtual machine gets provisioned quickly, but inside the virtual machine you have to install that software, right? The Hadoop related software. It's going to take little time. So that's where you will see around 4 to 5 minutes it's going to get created. So if I see my virtual machine screen, I see 4 instances. The -M indicates this is the master node. -W indicates these are regular worker nodes. Something very weird, secondary worker nodes. SW, this is nothing but your virtual, your preemptible virtual machine. So preemptible virtual machine, the instance should get created quickly. And all the virtual machines have external IP address because you did not do internal IP option. So it's going to take, so 22228 all in the same region. Yeah, so I should be fully utilizing my quota of 8 vCPU in a region. So should get provision if this, if we have provisioned it properly. Yeah, worker node is up, master, and the preemptible. This is preemptible virtual machine. How I come to know? The name itself is weird, and it always starts with SW, secondary worker. If I click on it, you will come to know it is a preemptible virtual machine. It is a preemptible virtual machine. The remaining stuffs are regular virtual machines. So if I click on the regular worker node, it's a regular virtual machine. So the best way, if you want to see whether it is preemptible or not, the best way I would say is command line is always a good choice in this case. I run it. So the VM gets provisioned quickly, folks, but the cluster takes time. So there's a question. Let me just run this command, then I answer that question. Gcloud compute instances list. It's going to show me whether it's preemptible or not. So there's a question from Mangesh. Whatever is possible in Dataflow, is it doable in DataProc, or Dataflow is only for whatever you, basically it's a distributed file, it's a distributed system. Wherever you want to do this kind of an ETL job, you can do it in Hadoop, definitely. Spark. So I would say both, in both the service offering you can do, but the approach is going to be different. How you are going to build it? There you are going to use a pipeline, Apache Beam pipeline to do the stuff. Here you are going to use Hadoop related APIs, Spark related APIs. Both are going to do the same thing. But if you see from the actual long run perspective, I would prefer to use Dataflow. No native, no vendor lock-in. It is open source, and it is going to have a better future. The reason is it can handle both batch and stream together. So that's always a better choice wherever it is possible. So it shows only one VM is preemptible. So let me see whether the cluster is up. It's going to take some time. So once it is up, right, what we will do is we will run a job. We'll run a very small basic job called as generating a pi value. a pi value, 3.14, a huge number. So usually whenever you run any provision a Hadoop cluster, right, it's going to have some sample codes built in. So which will be in your master node. You can go log into the master node and look into that sample code. We are going to use that sample code only in this context, waiting for the cluster to come up. So by the time this comes up, we can just explore the job. Let me see whether I have any jobs. I should not have any jobs. So if you just create a cluster, the cluster is of no use unless you submit a job. There are various types of jobs available. Submit one. What we are going to do is we are going to call this as batch 6 pi generator. And my cluster is in Singapore. So I'll select it. My cluster should show up. Now these are the types of jobs you can run. Hadoop, Spark, Sparkar, what I showed you in the slide. PySpark, Pig, all those things. Now the sample example, the code which I'm going to use is going to be a Spark job. So depending on the type of job, the user interface is going to change. So if I use a Hadoop or Hive is going to require something totally different. If it's a Pig job, it is almost the same. PySpark, it's going to expect a Python code where you have mentioned it. If it's a Hadoop job, it's going to ask for some jars because Hadoop related stuffs are mostly Java based stuff. So they are going to expect jar files. Jar stands for Java archive. So I'm going to use Spark where I'm going to mention the details of these stuffs. Don't need to worry about the details. You can get it from the cheat sheet. I'm also going to get it from the cheat sheet only. Where's the cheat sheet? This one. Type of the job, Spark. Type of the jar file or the main file is going to be org.spark apache.spark.example.spark pi. So to generate Spark value or Spark, I'm going to use this. That's my class name. This is in the Java terminology. And where is this code existing? You have to mention it. It's going to be on your master node. So if you go to your master node to this location, you should see this jar file. I'll show that once we finish this part of the demo. Copy this, paste it in the jar location. Then arguments, how many times you want to run this part. Basically, I want to run for 1000 iterations so that I can get something better. I can get a better value of pi. That's it, folks. This is what you need to mention. This is going to be specific to different types of job, and you are not going to do this. This is going to be done by a Hadoop guy who knows things working. But since we provision the cluster, I just wanted to show how you run a sample Hadoop job. So let me see whether my cluster is ready. Still provisioning. So this preemptible VM is creating an issue. I'm not sure. The cluster. Okay, the cluster is ready, folks. The cluster is ready. The preemptible virtual machine is also ready. Now what I'll do is I'm going to submit this as a job. Submit this as a job to my Hadoop cluster. So click on submit. If things are all fine, it should give me a pi value. So in next few minutes, it's going to give me a pi value, and this is going to run in a distributed fashion. So this is the log. So let's look at the log. Some warning messages should be there. That should be okay. Still running. The job is still running. Awesome. We got our pi value generated. Pi value roughly is this one. a simple example to show how your Hadoop or Spark job works on your existing cluster which you have created it. That's it. Now the job ran. After the job ran, no more further jobs going to run in this cluster. Means in the next 30 minutes, the cluster should be automatically dismantled. I don't need to do anything because there's a scheduled deletion set. So we'll just leave it. Maybe after 30 minutes when we come back, we should see that the cluster is going to be deleted. So before we move on to the next part or go take a break, I just wanted to highlight few things for people who have worked on Hadoop extensively. Um, this is not the user interface which you would like to do when you are doing something on Hadoop, because people who have worked on Hadoop will have a different user interface which they are so used to it: management console, distributed file systems, all those things. How do I get access to it? Is basically I have created these virtual machines, and if I use the network tag, there's a network tag. What I will do is there are some specific firewall rules if you open up, and this is in the documentation. So I'm going to create a firewall rule. Now you see that stuff which gets connected, what we learned. So I'm going to create a firewall rule to open up specific couple of ports. So I'll create a firewall rule based on a tag. So access Hadoop. What is that network? This network. And I'm going to use a specific tag. Any instances with this tag, this firewall rule should apply. I'm going to keep it as open. And two firewall rules, I got this from the documentation. So one is port 8088. One is 9870. These are the port. One runs the management stuff, the management console. The other one runs basically your distributed file system. So that's it. Click on create. I have a firewall rule with those specific ports opened. The ports are open. Now let me go to my virtual machine. Go to my master. Go to my master. Copy the master. Now if I do the master port 8088, I would see this. This is what a typical Hadoop guy likes to see. What are the current jobs running, submitted. So we had submitted one job or finished. One job we finished, right? It shows it is job is finished, successfully done. This is what a Hadoop guy usually expects, and there are few tools which they can see all those things. The other thing is basically the management console, which is on 89870. Hope my port is properly opened or the port is different. I'm not sure. Uh, is the port changed or did I give the right firewall rule? 1 minute. Uh, Firewall rules. It's not reachable. 1 minute. We should be able to fix it. It is applied port. Maybe the port is changed. Not sure. Okay. DataProc, GCP. That's correct. That's as per the documentation. Oh, avoid security. So the master host name, this one. This is what we did. We saw this one. The management console should look. Let me give a try once. I had seen this working. This is as per the documentation only. The new this thing Hadoop version. Okay, this is pre. Oh, it has to be HTTPS. I'm using the latest version of Hadoop. I'm not sure whether because of that something is going wrong. That's okay. That's okay. So basically, if you open the necessary firewall rules, we just need to know what is the port. I'm not sure what is the port. Let me give a try with, let me give a range, folks. I'm not sure what is the port there. I'm just going to give a range. Kerberos is there. So let me see whether the other port is going to work. No, it's not working. It's not working. It's okay. So, but I basically try to connect our firewall rule concepts which we learned by just opening the necessary firewall rules. You should be able to see the normal Hadoop user interface which a Hadoop guy usually sees. So you can do that basically. That's the key part here. Now, the job which we ran, right? The actual code was in the worker in the master node. If you want to see that, you can just SSH and go to the location which you had seen. Just if you wanted to know what is the connect, where the code is coming, all those things. So I'm in my master. So if I go to my cd/user lib spark examples jars, I see this. So if you see, I'm currently in this /user lib spark jars. So this is what you mentioned, and there's a soft link which maps to my this thing. So the code actually resides in your master, basically. So that's something on the Hadoop or the DataProc cluster demo. So what we will do is we'll take a 10 minutes break. Once we come back from the break, uh, the cluster should still exist per my understanding because we had given it as 30 minutes. So maybe by India time 9:15 or 9:10, the cluster should get deleted. If we don't match it, which if we don't see it also, no problem. We can go to our activity page. We can go to our activity page and you will come to know what has happened, who deleted this instance. That information is going to be captured. We can see that. So if I just see the last activity, it should be something on the metadata firewall which you created, all those things. So the time is in a different time zone, so don't ignore that part. So let's just leave it, take a 10 minutes break. Once we come back, we will see a comparison between Dataflow versus DataProc. Dataflow versus DataProc. So take a break and come back, folks. Take a break and come back. Let me stop the recording.
This conference will now be recorded.
All right, let's continue. So if I just refresh the page, it's going to still there. So the 30 minutes has not passed. So the cluster is going to be there. In few minutes or a few more minutes, it's going to go off. Maybe by, I guess, in 20 minutes or 15 minutes, it should go down. Basically, because there's no job, it should go down. And we will see that in our activity page. And we'll also see what is that specific service account which is going to delete this. So that's going to be an interesting one. So let's see that. So now we'll do a comparison because many of us have this confusion whether whatever it is possible in Hadoop, can I do it in DataProc, sorry, in Dataflow and vice versa? Answer is yes. But it depends on what's your requirement. For example, if you have a specific, let's say for example, if you have 30 jobs, Hadoop jobs working fine in on-premise, no issues, everything is working fine. But the only concern now is your hardware on which these Hadoop clusters are running are going to be end of life. There's going to be a hardware refresh which you need to do. Now, instead of doing a hardware refresh, the organization may take a decision. Why should we invest on the hardware again, have capital expenditure, all those things? And if they plan to move to cloud, then using DataProc is a good choice. Lift and shift. So if you have lots of dependency on Apache and Spark ecosystem, if the answer is yes, simply use DataProc. What is going to happen? This 30 jobs going to be running means assume there is going to be two data Hadoop engineers or anybody. So they're not going to lose job. They're going to do the same thing in cloud, and they're going to more focus on optimizing the jobs, because infrastructure wise is going to be fully managed by Google, so you don't need to worry. So the person is not going to lose a job, but they are going to do slightly different in cloud. So that's the option, and they continue working on the same interface which they have with Hadoop. If you say no, I don't have such dependencies or anything related to Spark and Hadoop, then you ask a follow-up question. Do you want hands-on experience or hands-on or full control to your cluster uh, stuff? If you say yes, I want more of hands-on, I want to, because I have a DevOps team, all those things, then you again use DataProc. But if you say no, I'm a startup, I don't have any DevOps team, basically I want a product which is going to be zero ops or no ops, serverless, then the best product is going to be Dataflow. I guess this diagram could have given you a better idea when to go with Dataflow, when to go with DataProc. So in the exam, if you get questions like where in on-premise there is a job running, Spark job running or Hadoop job running, fine. Quickly they want to move to GCP, then the option is just use DataProc. If they say they want to have a batch processing job which is going to be for futuristic purpose and which has to be future proof, then possibly Dataflow is a good choice. So I usually call something like this. The way I do it is, this is brand new systems which you're going to do is going to be called as greenfield. So if it's greenfield, I'm going to prefer to use with data. And please note, if it's already a DataProc job running, you want to move it to Dataflow, it's not a lift and shift, folks. Please remember, because it's going to be written in Java using Spark APIs or anything. If you were to convert that, you have to use Apache Beam pipeline. So it's going to be totally a refactoring or a rebuild, I would say. So it's not a lift and shift. So if you have Hadoop jobs, you say, no, I don't want to use Hadoop, I want to use Dataflow, a complete rework has to be done. Instead of that, what I would say is, if there is 20 jobs, run it in your DataProc. Migrate it, let it run it in DataProc. Slowly, if you feel you want to modernize something, maybe the 21st job, you can configure it in Dataflow so that it's going to be future proof. And these legacy systems may go slowly off, meaning just migrate it as is. Any new job, start with your Dataflow. That should be the approach. Hope this part is clear, folks. Difference between Dataflow and DataProc. There's a chance that you may get questions on this slide itself. Uh, so hope it's clear. Let me just see my cluster, whether it is there or it's deleted. It is there. So just wanted to show you. If we can see it is going down, it's going to be really good. So good. Now, we saw two different options. One was totally brand new, future proof, all those things. But the drawback of Dataflow was you need to write code for everything, which may not be so easy for a cloud architect who comes from an infrastructure background or from a non-programming background. Then was DataProc. Again, it was heavily relied on programming, that too on an existing ecosystem. Like if it's already running Hadoop jobs, you just migrate it. That's good. So both were relying on code primarily. Do we have something like GUI, graphical user interface, where I can do this kind of transformations, connect to various sources and do all those things? If you want something of that sort, more like your Informatica kind of a stuff, the product which you get in GCP is called as Data Fusion, which is graphically manage data pipelines. So where you can drag and drop what is your source. For example, we did a batch processing, stream processing, right? Where the source was PubSub, data flow was our ETL tool, and the destination or the sink was our BigQuery. Now, if it is a batch processing, your source is going to be Google Cloud Storage bucket. Then your ETL is going to be Dataflow, and your sink is going to be BigQuery. Now, if you have that kind of a batch processing, so GCS, Dataflow, BQ, BQ, you can do this one way. For this, you need to know Apache Beam pipeline, how to write everything, or you can use a template. The second option which you can use, DataProc, BigQuery. So you need to know Java code, how to do this. Or if you say, no, I don't know any programming, if there's an UI, I can do it. Then the option which you can use is something like Data Fusion. So you don't write a single line of code. Everything is going to be drag and drop. So where you add a source, you add a sink, you write all your stuffs in you put all your transformation rules in a simple user interface itself. So that's how this option is going to work. A little bit of disclaimer here. Uh, it's not something that I should say wrong about this, but my experience with this product is not really good. Um, uh, it's a product which was launched in 2019 along with Anthos and all. This product came, Cloud Run, Data Fusion, they came all in 2019. The maturity of this product is not that great. It sometimes breaks, sometimes does not even give you any details what's going on behind the scene. It's more like a black box. uh, so if it's working, all good, no issues. But the moment it stops working, you will not get a single information about why it is not working. So that's really a bad part, I would say. It works like more like a black box. And another bad thing which I see is the product is really expensive. So it's really expensive. If you forget to stop it, you will get a huge bill. You'll get a huge bill because it's going to use a concept called as tenant project, all those things. So it's slightly a expensive product. So it falls under the same category of our spanner and our big table. So please use it with caution. But this can come very, very handy. The good part is it can come very handy for cloud architects like us to do a quick proof of concept where you don't need to write a code. So that's a really handy option, I would say. So what is this? Let's explore it. A fully managed cloud native data integration service where you can build pipelines quickly by drag and drop. Everything is GUI based, and the UI is not that great, but it's still manageable. So you can drag and drop. And by doing this, what you're focusing is you're trying to derive more of insights rather than focusing on the code. You derive insights from those data and make sure make the data talk basically. And this product is based on an open source technology called as CDAP. So which Google acquired in 2018. So which they acquired in 2018, but they still keep it as open source. So meaning if you want to have data fusion equivalent of that in AWS, or Azure, basically just go to Seed app, you will get the download, install it on a virtual machine, do it. So you don't have a lock-in basically because the entire stuff is based on open technology. Now you will be very really happy to say Google primarily relies on most of the products which is going to be on open source technologies, except few products like your products like Spanner, then Cloud Functions, App Engine. So remaining most of them are going to be relying on open source technology. So that's really a cool part. A little bit about Seed app. Uh, so Seed app is basically as I mentioned, it was acquired by Google, but it is still kept as open source. So you can also go and use it. What you get is a managed version of Seed app, meaning you don't need to go set it up on a virtual machine or anything. Just go click on a button. It's going to provision. It's going to take roughly around 15 to 20 minutes to provision this entire setup. Then you should have a graphical user interface to access it. Basically, the key part is things are becoming now more mature, uh, more more traction is there, and I had really a bad experience with data fusion in the beginning. So we had to actually reach out to the product manager of Google. Fortunately, he was in India at that time, so was able to get some details and fix it. So we were trying it when it was in beta stage itself. So they had traction. So but still I see some issues are there with the product. So the big advantage is you can quickly do things, and a few weeks back I saw it can also help you to connect to SAP. So if you are if you are a person who works on SAP and all, so data fusion can connect to SAP systems and do some transformations and load the data into BigQuery or any other system in GCP. So you can use it. So it can easily connect to on-premise and other clouds also. I had done an implementation where we had AWS RDS, basically a Postgres database. Then we had to connect it uh, using a private IP. We use Cloud Data Fusion. Let me take this one. So AWS RDS Data Fusion and load the data into BigQuery. We did something like this. So it worked. And this was a project which took good amount of exploration. And this was in 2019 time period only, where the product or 1920 2020 time period where lots of issues with the product was there. It was still in beta. So took a good amount of exploration to do it, escalations, all those things. But still I see the problem still exists with the product. So not that mature, but slowly it's maturing. Now recently I saw something with SAP systems. My knowledge is very limited on SAP, but I saw an article on this. So and you can connect to any source literally, and the source, if it's not there, you can build your own source because the entire stack is open source. The entire stack is open source, so you should be able to do it. By doing this, the focus is more towards exploration. So you want to do a cleansing of data, you want to remove some deduplication, some transformation, just connect the source, use your data fusion, modify what you want, then run the job. It's going to run the job and it's going to put the content into a Google Cloud environment. It could be a storage, BigQuery, Spanner, whatever it is. It's going to do it. So you can create pipelines as easy like this. What is this pipeline? Basically, a batch processing pipeline where it reads from a storage, where it reads from a SQL instance, a MySQL instance. In this case, it you connect basically to that MySQL instance. Then basically what you do is do some kind of a transformation, and the transformed data you put it into BigQuery and also into Google Cloud Storage to sync one source. And all these things I can do without writing a single line of code. That's the beauty of this product. and this product takes little time to provision. So what we will do is we have around 50 minutes. It's going to take around 20 minutes to provision. So let me show you how it looks. And I'm going to share you one video, a private video where this entire implementation is done. You can look into it, but if you try to do it, it may not work. There is, as I mentioned, there are some issues with the product. So um, that's the reason I stopped doing this demo during the class, because it's going to create lots of troubles only. So instead of having it run, so but I'll show you how to provision the resource, how it works, and instead of a database, I will try to show you a demo where we will use a Google Cloud storage bucket, where there's a CSV file. You do some wrangling, data transformation, and put the transformed data into your BigQuery. Something like that we can try to do if time permits, maybe today if it gets provisioned, or maybe in the next class. So because the resource itself is going to take around 20 minutes, 15 to 20 minutes. And this is very clearly mentioned in the console itself. Let me show you how to provision this. Fully user interface, and that's the reason I wanted to give this demo, because we saw demos where you need to write a code like Hadoop and Dataflow. But if I don't do a demo on the product which you are going to use as a cloud architect, it does not going to make any justice. So let me do this demo either today or next Saturday, depending on how quickly the resource gets provisioned. So okay, the cluster is deleted, folks. The cluster is deleted. If I go refresh my screen, the last entry was at 12:10, because my time is in different time zone. So 12:10. So now 11:10. Now the time is 11:40. If I just refresh it, I should see an entry that cluster is deleted. The Hadoop cluster is deleted. And it will also show a service account. Now at 11:34, the cluster was deleted. So the cluster was deleted by whom? This is the service account. This is a service account, and the service account, if you see, basically it is service hyphen your project number at the rate dataproc accounts dot im dot g service account. So this is a service account which deleted our cluster, which was called as cluster hyphen batch 6. So that's good. Now let me go to my data fusion and show you that stuff. Data fusion. So let me click on data fusion. So as usual, the API is not enabled. A fully managed native enterprise data integration service. Very handy tool, but requires more enhancements still, I would say. Let me enable the API. The API is enabled. Now, if I go back to my data fusion, I'll just pin it so that I can easily navigate. Data fusion. So data fusion. Let me go and create a instance. Let me call this as batch batch 6 df for data fusion. You can mention the region where you want to provision it. I'll put it in US Central just for this demonstration, assuming it can be a little faster if it's in US Central. Various versions supported. I used a very older version in 2019, so now there are some mature versions there. Let me use the latest. And this is an important one, folks. The types of edition are the different types of data fusion which you get. One is a developer edition. So this provides full featured edition of products and this thing, but with a zonal availability. It's going to be a zonal resource. But when I go with basic, I get better stuff. It's going to be a regional presence. Regional presence, but you will have some limitations like you cannot do stream processing. Only you can do batch processing. So whenever you're doing any data pipeline, you have to have two options, right? With basic, you are going to get only stream processing. You can build batch processing, connect to any source, perform code-free transformation. Limitations: simultaneous pipelines, recommended for non-critical environment. The best option which you are going to use is enterprise version, which has no limitation. It can do batch and stream both, supports real-time pipelines and batch both, with data lineage, no limitation on number of pipelines which run simultaneously. Here, the number of pipelines which are going to run simultaneously would be limited. So yesterday I tried with a developer edition. It was damn slow. So I'm going to go with the basic edition. And anyway, we already did a stream processing using Dataflow. Why don't we use a batch processing using our data fusion? So where our source is going to be Google Cloud Storage bucket. So then you have some authorization requirement, which is nothing but our service account, IAM role related stuffs. Data Fusion does not have the permission to use a selected DataProc service account. Now you may see what is the connection between Data Fusion and DataProc. The thing is that data fusion is going to be more like a user interface, which gives you that nice drag and drop user interface. But when you click on run the job, it requires uh, a compute or an execution engine to do that. So one of the execution engine is DataProc. Basically, whatever you did in Dataflow or directly in DataProc by writing a code, you are going to do the same thing here, but without writing the code. So the code is going to actually get executed in a DataProc cluster. So Data Fusion, whenever you run a job, on the fly creates a cluster. Once the job is finished, it's going to delete it. So because of which you need to have this creation, there's going to be a connectivity between these two things. So to see this in action, if I go to my IAM, I can just click on grant and go ahead, folks. I have no issues easily, but I wanted you to understand the concept thoroughly. That's the main part. So this is the screen which you see. Now, DataProc service account. You can choose any of the service account which you want. You can choose any one of them or create a new one also. That is okay. I'm going to use my default. I'm just going to leave it as default. Compute engine default service account. This is the one. Currently, it has editor role. Now, when you click on grant permission info, what is going to happen basically is there's going to be a specific role, IAM role, assigned to this service account. If you want to know what is that role, basically, I'll keep the screen as is, duplicate it. You see another role added. So in the previous screen, if you see, it was only editor. By clicking on that grant info, grant permission, it added one more role called as Cloud Data Fusion Runner is what it indicates. So this is another role assigned to it. And if you explore this role, it's going to be only one permission. Only one permission, made of only one permission, called as Data Fusion Instance Runtime. And if you copy this permission and search in editor role, it will be already there. So it does not make a much difference if you are using I'm really sorry, folks. Today I have a bad network. I don't know. 3 times we got disconnected. Really sorry. I guess now it should be back. You should be able to hear me. So, uh, when it comes to basically, if it's already an editor role, giving this extra role is of no use. But if you have some other user-defined service account, then granting is going to make sense. Granting is going to make sense because in editor role, this permission is already there. The permission is data fusion dot instance dot runtime. So that grant did not do much changes or much important stuff for us basically. So US Central, the region, basic version granted the access. Now there are some advanced options. I would strongly suggest to only turn on logging. That's going to help us some logging, but private IP is really a troublemaking stuff. So we'll not even explore that part. So it's really troublemaking. It does not work very well. So that's it. Give a name, the region, it's a regional resource. If you make it as developer, it's going to be basically in a zonal resource. If you make it as basic, that option is not going to come. Enterprise is also going to be a regional resource. And here very clearly they mention it. The instance will take approximately 20 minutes. So if we are fortunate enough, we may at least see a small piece of the demo, which I'll continue on the next Saturday. But if the instance does not even come up, I will recreate it next week again. Maybe I'll have the instance up and running ready and we'll come back and explore it. So let me click on create. It shows you something like this. Don't worry, the interface is going to come up. It shows the instance is going to be creating, but it shows nothing. So I have to refresh it. Now you see it yourself some bugs. The bugs, I'm not sure whether should I click it one more time. I'll not create one, folks. I have seen this kind of stuffs happening, saying that the cluster, it's going to quickly afterwards show something. Okay, looks like it's not there. Let me create one more. These are the known bugs. You see it by yourself. 2, I'll just call it as 2. US Central, latest version, basic, authorization is done, and I will turn on logging. Click on create. Hope it works this time. Okay, you see this, folks. These are the known bugs. One, it shows it is running. Now when I created another one, it shows 2 things are there. So these are some very funny stuffs, and you don't get access to do it in command line. You have to do this in UI only, which is another bad part of it. So I have to delete either one of them. Let me try to delete this one. Or we have to wait. We refresh it. It did not work. So when I created, it shows it. So buggy, little buggy. So this is going to take around 20 minutes. So we may just see a basic version of it. We'll explore it in next week's class. So anyway, since it's going to take time, I'm going to share some information on the pricing part of it. Some pricing part. So let's explore, because this is a little pricey product. Let's explore the price details. So developer edition, it's going to be basically it's per hour charge. It's more like your spanner. It's not an per second billing, it's a per hour billing. So if I use developer edition, it's going to be 0.35 35 cents. If it's basic, I have to pay $1.80 $1.8. Enterprise is going to be too expensive. So you can see, if I just leave the instance running like this, data fusion instance running like this, enterprise, without doing anything, I'll be easily charged $3,000 in a month. So this is really tricky. One of the organizations where I worked, somebody created a cluster like this. Sorry, not a cluster, a data fusion instance like this, and just left it. And it charged almost like 5,000 USD for them. So little tricky there. And with the basic one, what at least you'll get is the first 120 hours is free. So that's what we are currently using it. Because it is free, it has lots of issues by itself. So let me see other something is going on. So that's something on the pricing. So complete comparison, if you were to do it, basically the developer edition, the number of users who can do simultaneously is going to be 2. Workloads, what can you do? You're going to get a visual designer. This is the canvas where you will drag and drop. So what you saw, this is a canvas visual designer where you can drag and drop your details and do the changes. So you get that in every edition. So you get lots of connectors. That's one good part, I would say. You'll get lots of connectors which you can easily use it. Uh, Private IP support is there, but it does not work very well. Streaming support, streaming pipelines, they say is it supported? Streaming pipeline, as per my understanding, is only supported in enterprise, not in this thing. So I need to verify this. So this is a zonal resource. All other stuffs are regional resource. Uh, you can run simultaneously multiple pipelines. So one good thing with enterprise edition is you can do a chaining, meaning after one pipeline runs, only then the next pipeline should do. You can do that kind of chaining the stuff. That's going to be really helpful. So let me just add this in the cheat sheet. Cloud Data Fusion developer. This is going to be zonal as per the documentation. Cloud Data Fusion basic slash and I would say basic and enterprise. So slightly drag this. So this is a regional resource. This is a regional resource. Let me see any progress in my this thing. There are two this thing. I'm not sure what's going to happen with that. Okay. So it's going to take time. So by the time this comes up, we'll explore another product. I guess we may explore that product itself by the time this comes. So this is also a kind of data integration ETL kind of. It's more than an ETL tool is what I would say, because it can connect to various sources easily. You can do that integration. So it's ETL process is going to be part of it, but it has a bigger picture like data integration, all those things. So that's where data Fusion comes very handy, but this product is little expensive. So if you look into the order of the products which was launched by Google, so the order in which it was launched, order of sequence of products, ETL data integration products launched by Google or GCP was the first product was basically I'm not sure whether it's going to be Dataflow and DataProc came up I guess DataProc first. DataProc, then was Dataflow. They were being there for a long time. People really felt it was little difficult to write code in Dataflow and all. So what they did was they had a tie-up with a partner organization called as Trifacta. This is a partner implementation. So they released a product called as Data Prep, and this was from a partner called as Trifacta. So later in 2019, they released Cloud Data Fusion. Google Next 2019. So this is the order, folks. So what we have seen is we have finished all the 3 Google products. You can see it in the GCP console, and we finished it. But literally speaking, I would say we should have taken this approach: data prep, afterwards data fusion. But I thought, let me show first all the Google products, GCP products, then show a third party product. That's the reason I made it as data prep lastly. So that's what we are going to see now. Data prep. So as the name itself indicates, this is going to be used for some kind of an ETL process where you're going to use this process for cleansing the data, detecting anomalies in the data. What are the various anomalies? The anomalies could be something like missing values, then outliers, duplicate entries. These are all going to be possible choices which can be easily removed using a graphical user interface. That's the beauty. So you don't need to write a single line of code, and it is going to be a SaaS offering. So because it's a SaaS offering, you'll not have the problem like what we are having with our data fusion, which takes around 20 minutes to provision. So this is SaaS offering, just drag and drop things works, and you do everything in the UI. And the beauty is once you submit the job, behind the scene, it creates a data flow job for you in Java. So instead of you writing a code and creating a data flow pipeline, either you can use templates or you can use data prep. So which behind the scene which uses Apache Beam and executes the code on Dataflow. That is what it's going to do. So without writing any code, without you writing a single line of code. Data fusion was also on the same lines. Now you may ask why Google has 2 different products. One is a third party product, a partner, other one is their own product. Now to just give you some insights why these 2 kinds of products exist, I can share my own experience. When we do the demo on data prep, I'll show you the screen, what and all the screen expects you to give as a consent. So the screen is going to, because it's a third party, right? Now if it's a very large enterprise, before they start using GCP or any cloud, there's going to be a legal team which is going to vet it, whether this GCP is good, any legal compliance, anything, everything they are going to verify it. Only then the product is going to be used or the various services are going to be used. Now they would have already done a vetting saying that, okay, go ahead, in our organization we can use GCP. We don't have any issues. But if you use a third party product like data prep, you again need to go through the legal process. So, and data prep expects you to share some of the data. Because it's a SaaS offering, you will not also know where your data processing happens, where the data temporarily gets stored, all those things, because it leaves basically Google Cloud and then comes back to Google Cloud. So in that short period, we don't know where the data gets resided. So that compliance comes into very, very important picture. So because it's a third party product, in one of the real POC, we wanted to do this kind of a processing. So we asked the consent from the customer. It was a proof of concept only, folks. When we asked, can we do quickly using data prep, they told no. Straight away no. The reason is it's a third party product. If it was a Google product, they would have accepted it. But because it was a third party product, they told straight away no, don't use it. Even if the POC takes 2 weeks, no problem. Do it using data fusion. So that is the stuffs which you will get in reality. So, but this product is really cool, lightweight. You can do things in few minutes. Stuffs. It will be up and running easily. So in the exam, I had got a question related to data prep, both in my first time 2018 and in 2020. The question was related to anomalies. Something like this. The question is something like this. You want to detect anomalies in your data, or your data is not so clean, you need to clean it, but you have to do this quickly. What are the options? So one of the options was data prep. Just mark it and go ahead. That's it. So anomalies could be various things: missing values, outliers, all those things. So we are going to do this thing basically what we are going, this is how the user interface looks like. We'll do a demo also. What it looks like is this. You have a CSV data, just upload it. That's it. Just upload the data and it's going to show some statistics without you doing a single line of code, folks. Beautiful product. So it shows how the data is distributed, if it's a uniform distribution or it is not uniformly distributed. Is there any missing values, duplicates? In one single shot, it's going to give as a summary. Now, for example, if I look into this department column, explore details of that department column, it says the top values are this. There are some mismatch values. Most of the department values are numerical, but there is some alphanumeric character which shows that as a mismatch value. This is an anomaly. Outliers. Most of the departments are 2-digit number, but there are few departments which is 3-digit. So this is an outstanding or outliers. It shows that. So mismatch values. So quickly, without you doing anything, it shows you the stuff by just loading the data. That's the beauty of data prep. So let me show you the demonstration. And I'm going to use a data which is already uploaded. So I'll show you the data, how it looks like. This is the data, folks. And this is the French data. So you may see some names which is more like French, not like English. So this is the data which is tab separated. This is tab separated. And the same data is what we are going to load into our Google Cloud Storage bucket for Data Fusion to process it. So since the Data Fusion is still taking time, oh, it came up. So good, Data Fusion came up. So what I will do is we'll do the Data Fusion part first. Then we'll do the data prep stuff, but the source is going to be same. We are going to use the same source for doing everything. So first, let me explore how this data fusion looks like. So because it is going to be all user driven, there's going to be a UI which you are going to get it. Just click on this view instance. So this is the user interface, folks. You do everything in here. So lots of features, data governance, you can do wrangling, you can do integration with various sources, you can do lots of stuffs. So what I'm going to do is show you this hub. It shows the various products which you can integrate. AWS, Azure, because it's basically based on open source, right? You get lots of tools to connect and do any kind of data integration. This is very, very beautiful. So you can see Azure stuffs also. You see AWS stuffs also, and you see also GCP stuffs, some other components also, like IBM DB2. We know we don't have an IBM DB2, but we can connect to IBM DB2, do some wrangling and push it to BigQuery. You can do that. So there are lots of such options. So this is like a huge hub. If you want to add something new, you can also add it. And I also mentioned, right, SAP integration is coming. So that is also there. So you can also use SAP. So good amount of sources are there. You can leverage it. What we are going to use basically is, if I go back to my Data Fusion home screen or home, we will load this CSV file into a Google Cloud Storage and do some transformation by just dragging and dropping it. Changes. Let's see how it's going to work. First, I will put this into a Google Cloud Storage bucket. Because it is for data processing, I'm going to put it into a processing unit. Do I have something? Yeah, this one so not this one, sorry. Yeah, this is the one. I'll just put, this is the regional one. So I'm going to put it into this bucket. That CSV file, data prep.csv. I've added it. I don't need this bucket content or folder anymore, which we created for our stream processing. I don't need it. I'm just going to remove it. So this is my source. This is my source. My destination is going to be do some transformation without writing a single line of code and dump it into BigQuery. That's what I'm going to do. So using data fusion. So I'm going to do some transformation. So I have to use Wrangle. So let me click on Wrangle or Wrangler. So by default, it's going to show the various connectors which you can use, a database. So if I click on database, you can connect to any of the popular databases, Oracle, MySQL, Postgres, SAP HANA. You just need to install their specific drivers and do it. So in the video, which I'm going to share you a separate video, you will see a demo where I have connected to a MySQL instance and do it. I was planning to show you that itself in the class, but yesterday I tried it, it is not working and it does not give any such details why it is failing. So, but I'll share you that video. You can look into it so you can have an idea how things can work. So various databases, Kafka, S3 bucket, Google Cloud Storage bucket, everything is available. So I'm going to use Google Cloud Storage bucket. The bucket which I'm going to use is this one. I have this data. So just click on this. I guess I have to double click on it. So when I double click on it, it's going to show me this data. It shows as one single column, folks. You see the column name is body, nothing else. So the same data is what you saw in your Notepad++ in my local machine. So they same format of data, but it is not even shown as comma separated. It should show as tab separated or comma separated, something of that sort, right? Only then I can do wrangling. Only one column is there. You see column, only one. Now, if you were to do a explode or split, basically you want to do a split by tab, you have to write a code in Python, Java, all those things. But since you're using data fusion, you can do everything via UI itself. How do I do it? Simple, just click on this. So this is a transformation, folks. One row transformed into multiple, one column transformed into multiple columns. So I'm going to mouse over parse a CSV file, and the delimiter in this case is going to be tab, and if I just cancel it, the first row, if you see, it's a header. So I'm going to treat my first row as header and it is tab separated. So that's what I'm going to do. When I do it, what's going to happen is 1 2 3 4 5 6 7 8 9 9 columns are there if I have counted it properly. So you are going to see totally 10 columns. Basically that's what it's going to have. This is one kind of transformation. So when I do the transformation, under your transformation steps, you're going to see one recipe or one transformation. So let me do this. Parse CSV format, tab separated, set my first row as my header. Click on apply. My first transformation done. You see 10 columns already added. Beautiful, right? You cannot, if you were to do this, you have to write a code in Python or Java, in Dataflow or in DataProc. Here I just did it via simple script, via simple user interface. Now this column is not of importance for me because I already have the better columns. So this one having the complete set is of no use. So I'm going to delete this column. So this is basically another transformation. So the first transformation is parse your body with tab. That is this is the actual code. You did not do that code. You just use the user interface. I don't need this column. So I'm going to click on this column, delete the column. This is my another transformation. So there are two transformations which I have done. So now I have user ID, department, blah, blah, blah. So around 10. Now you see a small red color here. Why it shows that red color? Basically the data is not complete. There's a column, sorry, there's a column which is empty. The department cannot be empty. So what you do is basically you can drop this value. So you can put a rule: if the department is empty, I don't want that row itself. You can do that kind of stuff. Or if the department is empty, you want to set a default value, you can set it. Any of the thing you can do it. So I'm going to basically, what I'm going to do is click on this each column, which what you want to do, you click on that specific column and do the changes. So what I'm going to do is filter, or I'm going to do filter. Okay, filter. What I'm going to do in filter, remove rows. Remove, if the value is empty, remove the complete row is what I'm going to say. So if I do this, what's going to happen? Basically, this first row, which is having total as 71.17 should be gone. So this is the transformation which I'm doing. So filter, remove it, or you can fill empty cells with some values, your choice. You can do whatever you want. I'm going to remove it. This is one more transformation. Did it happen? Yes. Now you don't see that red color, and you also see the completion. It is all 100% complete data. And since most of us are comfortable with English, not with French, I'm going to rename this column name to department. So this is another transformation which I'm going to do. I'm not comfortable with this name. That is also a transformation. So totally 4 transformations is what you have done. Pass the table, dropped one column, used a filter, then rename the column. So all good. Now we have done everything on this. This is on the sample data set which you got. Now what I will do is I'll use this as my pipeline. So to do that, just click on create pipeline. It's going to create a pipeline for me, and it shows 2 different options, batch and real time. Because I used basically Google Cloud Storage Bucket, it shows Google Cloud Storage Bucket does not support batch processing. So sorry, stream processing. I have to use batch processing. Let me use it. Now you should see that visualizer, the design utility, where you can put all your stuffs. Now you see this, folks. This is the input, is your bucket. You have done some wrangling, and you can see the details of the wrangling which you have done, the various wrangling which you did. All those things are going to be shown here. So these are all the stuffs called as recipes. That's good. Now what's my destination? So my destination is going to be, so you can see lots of sources here, spanner, all the most of the Google Cloud Storage, Google related products are there. So if I cannot minimize this. Okay, so I go to sync. I will take BigQuery. This is my BigQuery. Now after doing all the transformation, dump it, just connect it. That's it. Now you can click on align. It becomes a nice stuff where I do some transformation and put it to my BigQuery. Now you want to have the transformed data also stored in a Google Cloud Storage bucket. You can also do it. Go to your sync, take your Google Cloud Storage bucket. Good. Now connect it. Done. Align it. So this is basically that canvas feature which you get. Drag and drop, have multiple stuffs. Now one source, do some wrangling. Once it is done, please dump it into a Google Cloud Storage bucket and into a store another into a BigQuery. That's what we have mentioned. So you can give different names, all those things. Now, when you said you want to dump it into a BigQuery, let me know what is the data set, all those details. You have to provide that. So what I will do is basically I'll click on this properties. I have to give that details. Give a name, BigQuery sync. That is the name. Project ID, you have to mention the project ID where you want this to be dumped in. So let me go to my BigQuery. BigQuery. Because I created my data fusion in US Central, I would better prefer to create a data set in US, folks. Data fusion demo. I'll create it in US. 1 day should expire. That's my data set. So, and my project ID is this one. So let me copy my project ID, mention that under here. What is my data set name? Uh, Data Fusion. Mention that, and you can give a table any name of your choice, and you don't need to create the schema. It can create the schema when it is, if it's required. It's going to create it automatically. Batch 6 DF. That's the name of the table which it's going to create. It's going to by default insert, and if the table is not there, it's going to create basically the table for me. And in my BigQuery, I'm going to have all this as my details. The schema is going to be created like this. That's it. So just give the necessary details. Click on validate to see everything is fine. Validate is good. So my one sync is created. Let me create my another sync, update my another sync. So I'll call this as sync BigQuery sync reference GCS sync. Give a bucket name. So you have to give it in this order. So path output. So GCS colon slash slash. Let me create a new bucket, folks, in US Central only. For quick, this thing I'm going to use project ID. Don't use this, but and since we are running short of time, I'm going to use this. Make it a region, that too in US Central, standard one. And I'm going to create a folder like called as DF. So inside this, I should have the content, is what I'm saying. So yeah, this is how I should give. Copy my bucket name slash DF slash output. So it's going to create a file with the files with the name output hyphen something something. And it's going to also have suffix with your date, time, all those things. That's it. I guess I will just validate it to see whether it is going to work. Just gave the sync details. Okay. Format CSV is what you wanted to export it after the transformation is done. So good. That's where this validate command comes very handy. All good. So now everything is good, folks. I have my canvas. Everything is good. So is it clear till now? So drag and drop, how the canvas works, all those things. Is this clear so far, folks? Thank you. So now I have created my pipeline. Everything is good. Now save it. Saved. It's all good. Now go ahead and deploy it, folks. So this is a pipeline. You can export, import, all those things you can do it. Go ahead and deploy it. So by the time it gets, what do you mean by deploy is the canvas becomes a not an editable format. So if it's not in deployed state, you can go and edit it. Now I cannot edit it. The canvas becomes read only. And I also told, right, you can do some triggering based on only if this triggered, this pipeline should trigger. After this pipeline is triggered, it should be sent as an output to another pipeline. So this part you can do it very easily with Data Fusion. So now what I'm going to do is I'm going to run this job. I can also schedule it when you want to do it, all those things, all cool features works. So I need to just configure my job to run. So this job, all the stuffs which you did is going to create basically a DataProc job, and it's going to run it on it. So meaning if I go to my DataProc, currently you don't see anything. So let me just wait. There's no DataProc cluster. But when I run this job, it's going to create a DataProc cluster for me, and the job is going to get executed. Okay, that's what is going to happen. But don't be in a hurry to run it right away, because we are using free trial account. We have some quota limits. So what I would suggest is to click on configure and downgrade your DataProc cluster, change it slightly so that you don't have any quota issue. So one master machine type, I can make it as N1 standard. One core, 4 vCPU is good enough. 1 terabyte I cannot afford, so I'm going to make it as 30 GB. 30 GB, and it has to be standard persistent disk. Similarly, master, I want basically one machine type, one N1 standard, but not 2 cores. 1 core is enough. Memory, I cannot afford to have this much because of quota issues, folks. That's it. So 2 worker nodes, each with 1 core vCPU, and storage 30 terabytes. A slight customization is what I have done so that I don't hit up with my quota issues. Done. Now save this as your profile. So this is the profile in which I'm going to run it. Behind the scene, this is going to create a DataProc cluster for us. Now all good. They're all good. Just go ahead and you have those options of, you can also send some runtime parameters if you want. So in this time, it's only a standard one, so I'm not going to pass anything. I'm just going to click on run. So if things are all fine, at least in the next 10 minutes or so, we should see the job running successfully. So currently it was deployed. Now it shows provisioning. So during the provisioning state, it's going to behind the scene create a DataProc cluster for us. You see this, folks? CDAP, DataProc cluster, created in US Central, 2 worker nodes. So this cluster will take around 5 minutes. Once the cluster gets created, you should have this job running. If the job runs successfully, we should see the data in our BigQuery. Inside this data set, we should see a table called as what the table we gave. The data should be inserted, and we should see a content inside this Google Cloud Storage bucket. Now, we did not literally write a single line of code. So that's the biggest benefit of data fusion. So it is provisioning still. You can keep a track of this. It has to become complete. Only then we should be able to do it. So let's wait here. Folks, I may take 10 more minutes of your time. Sorry, this data fusion takes longer time to provision. So 10 minutes, then we will stop it. So if you were to edit it, all those things, you can again do basically a copy or a duplicate. If you were to edit it, maybe you want to add one more destination spanner, for instance, you can duplicate this, go edit your stuffs on the canvas or on the visual designer, add it. You want to do any modification, you need to duplicate it. So when you duplicate it, it's also going to have versioning. So version 1, version 2, version 3, like that. Let's hope the logs comes up very well. Not yet there. My cluster is going to take a few more minutes to come up. I can see it in my virtual machine. So these are all connected cluster. So it's going to be virtual machine. I should see 3 instances. So 3 instances, the instance is up, but the cluster with all the Hadoop related stuff should get provisioned. So it should get created. And if you are interested what kind of job it runs behind this, this thing, you can search for scoop. This is a scoop job which it creates behind the scene. So it does not show you that details here, and scoop is not a supported job here, but behind the scene it uses scoop. So if I click on submit job, scoop is not there, but data fusion uses scoop jobs behind the scene. So let's wait for the cluster to be up. First the cluster should be up, only then the next process is going to happen. Okay, the cluster is up. Good. Now you see from provisioning, it became starting. So deployed, provisioning, starting. So now the job should have some logs. It's going to take little time to show it. Um, and it's not so user friendly like your data flow where you can click on each DAC and see it. It's not going to show that way. So we have to see. Now starting, it came to running state. So 3 minutes it's been running. So let's wait for some logs to show up. And it is pretty slow, folks. That's what I have seen. Lots of heavy lifting works are going behind the scene because it's all UI driven. So lots of stuff's behind the scene. DataProc is there. We have to wait. At least the log should start populating. It should show something like read it from storage bucket. Table is not there. I'm going to create a table, then insert it, something of that sort. So let's wait maximum for 10 minutes. If it does not show any error, that's good. The logs takes a longer time to populate. Any questions so far, folks? The whole reason why I showed this demo was because this is going to really help you where you are not going to write any code. The only thing issue is the problem is the product has little bug. So more like the IBM database BI tool. Okay. Okay. Working on the same tool. Okay. Good to know that this is called as data stage. Okay. This is called as data stage BI tool. Okay. Good to know that, Mangesh. So let me see the logs. Okay, so some information is coming up. So batch 6 started. It says the table does not exist. Using input string for writing the records. Good. So we should wait for a few more minutes for it to show up. We'll wait till 10 minutes when it shows 10 duration, hoping for it to finish it off. And the reason why it takes good amount of time is you have not written any single line of code. So it's going to generate everything behind the scene. So it's going to take some time. That's the key part. And there is no option of uh, stopping this data fusion instance, folks. Either you have to leave it running or delete it. Every time when you delete and start it, you have to wait for 20 minutes. So you need to take a call whether you want to really keep it running or not. So the best option is make sure you delete it. If your job needs to run at 10 o'clock in the morning, maybe at 9:20 or 9 o'clock itself, you start it. Once the job is all done, all those things, you go and delete it. So that way is going to be a better choice because this is going to be hourly rate charge. So it's going to be a little expensive. So, okay, some few details are coming up using this path, something. So some few things are logging. So good at least. So far, we have not seen any. So we have not seen any errors so far. Let's wait for it to show. Fingers crossed, folks. Usually, always towards the end, it shows error. So everything is correct, which we have given. Let's give it wait for 2 or 3 more minutes to see if it shows up. Yesterday, I tried something similar. After this, it was taking longer time. So I did not have that patience. I just stopped it. Let's just give few minutes. It should show the next information. So far, there's no error. There's no error. I've turned on all the log levels. So far it's good. Now I wanted to give you a real picture of this. So easy to build, but time it takes to show you the stuff, it's going to be a little longer time. So let me just refresh it and see if there's anything there. Wow, awesome. So there's a folder created, output with a time format and a temporary data. Okay, this is not the one which I wanted. This is some temporary data. So we have to wait for our actual data to be created. This is temp data. Nothing is there. So it's using some storage. Okay, let's wait. Can I see anything in BigQuery? If it works, it's going to be good. Last batch, we did not do this actually. So this had lots of issues. So I had a previous batch video, I shared it with them. Batch 5, still not there. Looking at the logs, still not there. No errors, still not finished. Because anyway, from first content is there. Who knows? They may ask something on data fusion. So that's the reason I wanted to show you this part. Still in the same lines, not even progressing. I can, because we have turned on stack driver logging, I can see whether I can show you the logs. Let me see whether I can, instead of simply waiting, why don't we use this time to see something? So data fusion. So can I see the logs, better logs? Did I turn on logging? Yeah, I have turned on logging. Let me see whether I can see the log to see something better. Is there any errors or something? So logging, Explorer. Okay, it shows some of the stuffs on data fusion only. So you see all are related to CDAP logs. You see this CDAP logs. So at least this is good. Some log information, or you can put a filter on data fusion data. I have to see it on DataProc. Okay, I have to see the logs of DataProc only. Data fusion does not have a logging here. What I see are these logs are generated from DataProc. So if I click on one of them, expand it, basically DataProc clusters, that is the log which is showing. So it's still running. Okay, 11 minutes passed. Any further log information? No. I'm not sure. Should I keep you people waiting? 2 minutes, 15th, we'll just stop it, folks. I'll stop it. I'll but keep recording it. You can log off. I'll wait for 15 more minutes. Once it does, I'll just close it. So it's going to basically show the table inserted and the records basically should be there. That is what is the expected stuff. It's taking a good amount of time to do it. If it does not work, if it works or not works, I'm going to share you another video which had worked basically for your reference, where the source was a Cloud SQL instance. So last 2 minutes, afterwards we'll stop the class. If you have a hard stop, you can log off. I'll wait for 15 more minutes and then see if things works. After 15 more minutes, if it does not work, I'll just stop it and I'll give a try later sometimes. So far, no errors. But for a very few amount of data, it should not have taken this long. Sometimes I doubt whether it's because of basic edition. If I use enterprise edition, it's going to be better. Sometimes I get a feel of that. Let me see whether it works. Once it is successful, it should show as succeeded. So it should show something like that. So no entry in the logs. It's the same thing which happened in the morning, in the yesterday when I was trying it. One last minute, we'll stop it. You can also log off. I'll wait for 15 more minutes where I'm not going to talk. I'm just going to keep recording it. If it works, good. Otherwise, I'll stop the job. If there wasn't any error, at least it should have shown, but looks like there's no error. The only thing is that it's going to take longer time is what I feel. No scope of improvement. I'm just refreshing the BigQuery stuff to see whether there's any table created. No. My Google Cloud Storage bucket. No. Still running. The log, nothing much logged after that. So if I see this log information, do I get any errors? I don't see any errors. All right, folks, I don't want to keep you waiting, so we'll stop it here. So if you have a hard stop, thank you for giving me 15 minutes more. We'll stop it here. I'll just keep the video running. See if it gets done. I'll just record it. Otherwise, I'll just stop the process. Okay. We'll stop it here. When we resume back on next week, we'll talk about data prep demonstration. So it's going to be so quick there, but you will have those constraints of it as being a third-party tool, all those things. We'll see that part. Next week, we should be able to finish our Saturday. We should be able to finish our big data, and on Sunday, we should finish our AI components. Okay. So we'll stop it here, folks. So I'll keep recording it for the next 15 minutes. If there's anything which works fine, it's going to be recorded. Otherwise, I'll stop the instance. All right. Let me stop it here. You can drop off, folks. Thank you.
No, my just one thing actually.
Yeah, go
Uh,
ahead.
my account is expired actually. That free trial account.
Yeah, 3 months.
So,
We took more than 3 months. Yeah.
yeah.
You have to create a new one. You tried creating a new one?
Okay, I will try today. And
Try.
can you add, once created? I mean, I will let you know. And then can you add me in that project?
Add you in where?
That learn GCP project. Which
No, no,
we
no.
created.
What you
Okay.
need to do is you have access to one of your Gmail ID which you have already given. So that is going to continue. So
Okay.
access to your video, YouTube to the video, private YouTube video and material is all to a Gmail. So
Okay.
you can use that Gmail continue. Only a
No, not
subscriptions.
that one. That project you created, right? In that learn GCP project console.
A group where I created and added you people. Is that what
Yeah,
you're
yeah.
saying?
Yes, 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 yes.
Okay, that group is for just for a dummy purpose for learning. So I guess I deleted the group itself. So I
Okay,
don't
okay,
have the
no
group
problem.
now. So it was just for to show you how the group works.
Okay,
So no need of that. No need of
okay, okay. Thank you, thank you.
Yeah. But Mangesh, I've heard that last 2 weeks there's some issue with the free trial account. People are not able to do it. You may also have a challenge. Give a try couple of times. Afterwards, stop it. If it gets
Okay,
detected, but your account does not get activated, don't try too many times. I've heard
okay,
it from last 2 weeks. There's an issue.
okay, okay. No problem.
Okay.
Thank you. We'll try
Maybe
and let you.
sometimes later we can. Yeah, yeah, yeah. All right, folks, we'll stop it here. I'll record it for 12 more minutes, only silence. If it works, good. Otherwise, I'll stop the recording. Thank you, folks. Okay, I guess, folks, because there's some warning messages. It indicates the resources are not sufficient is what it indicates. The has not accepted any resource. Check your initial job has not accepted any resource. Check your UI to ensure the workers are registered and have sufficient resource. Not sure, is it because of the quota? Let me see the machine types. One vCPU. Okay, maybe let me try stopping this job. Maybe the configuration needs to be little high. So needs to be little high. Let's give a little high configuration and give a try. I'll just wait for 10 minutes. If it works, good. Otherwise, I'll try to find a different fix for it. Basically, uh, the job is should be stopped now. The job is, if the job should be stopped. It's still running. Stop the job. Okay, it is stopped now. What I'll do is I'll just click on the configuration, slightly change this machine type with a decent configuration. One more, I'll give it as 2 cores, folks. 2 cores, 8 GB RAM. Two cores, 8 GB RAM. So little powerful. Let me see whether the cluster is down. Otherwise, I'll have quota issue. So I'll just wait for the Hadoop cluster to go off. Then I'll provision the new job. So looking at the error message, it sees that I have to have better configuration. Just giving a try. So let's wait for this cluster to go down. Job is, yeah, it is deleting. So once it gets deleted completely, I'll run the new job with a better configuration. So I'm giving two vCPUs, so 6 vCPUs is what you should have. So we should be still under the quota. Maybe it may work. Let's give a try. The cluster is deleted now. So let me go save this. So let me run that job. It's provisioning. It's getting provisioned. It's getting provisioned. So it's a little better configuration. So let's see whether it's going to do anything. So wait for the cluster to get provisioned. Having a different machine type, let's see whether it's going to work. So I have changed the setting. Waiting for the cluster to get provisioned, folks. Once it provisions, I'll wait for 10 minutes. Job should get created. Let's see what happens. Okay, the cluster is provisioned. Now, if I go to my data fusion, it is starting, is what it indicates. Looking at the logs, I guess last time I was only looking at the normal logs. The advanced log is going to help us to show what is happening. So I did not click on this advanced logs. Now I am clicking on it. So it should show. We'll turn on all the logs. So the mistake which I did was not clicking on the advanced logs. So this one is going to give us something much better. So it is running. The logs should give us better choice. Click on. Okay, I see some errors. That's warning. It's just a warning. So I'm just going to wait for 6 more minutes to see if things, at least those warning message which was showing previously, is going off. So if it goes off, then it's basically because of the machine type, I would say, because now we have a pretty decent machine type, 2 vCPU, 8 GB of RAM, and because it is this one, it's a custom machine type. So fingers crossed. Let's see whether it's going to work. Let's see. So some more logs are coming up. So if I click on just the logs, but the advanced log shows more information. Okay, using the schema. So good. Hoping it's going to work. Basically, importing. Let's see. Let me just refresh this. Maybe I'll go back. This one. Okay, success. I see the data has been come up. So I guess, yes, awesome. So the machine type was a problem, folks. Gave a very less machine type. After making it little better, basically, the configuration was in 5 minutes it ran. So sorry for keeping you waited. It was the machine type which was wrong. The machine type which I gave was now a little decent configuration. 2 vCPU, 8 GB of RAM, and the worker node is also 2 vCPU, 8 GB of RAM. So that made the job successful, which indicates if I go to my BigQuery, refresh it, I should see a new table. Let me show you that. Now expand, you see this table, and this is a partition table. Uh, This is the table which got created. Partition, the details are going to be shown. If you look into the preview, you see the stuffs. The table name was changed. That is something which we did. Then we had dropped one couple of columns. So that's it. The transformation is done. So around 28,986 rows are been inserted beautifully. Now we had one more sync, if you remember, what that was our Google Cloud storage one. So what I'm going to do is if I go to my storage, this was the last one which I ran. So success. So 2.3 MB. So if I just launch this Cloud Shell and view the data, I should be able to see the transformed data. So let me just show you by just launching it. So if I copy this, so GS utility cat GS colon slash slash, just to show you the content, how it looks like part. And because it's going to be in Hadoop, right, you will have this kind of distributed stuff, part 00. And you should see the stuffs. The 28,000 rows, you should see it, folks, basically. So that's it. So now the job got finished. If you see, it has succeeded. Now, if you go to your DataProc cluster, the cluster will not be there. The cluster will not be there. It's going to be completely remote. So only when a job is running, the cluster gets created. Once it's done, it's going to be finished. So that gives a clear picture how a batch processing works. So the key part was the machine type. So apologies for keeping you waited for 10 minutes. So the machine type fixed the issue. All right. So now please make sure once you finish this demo, go to your data fusion and delete the data fusion instance. That's very, very important. Delete this. And after 10 minutes or so, come back to the data fusion and see whether it has been completely removed. Sometimes it is not going to be deleted. Please make sure you delete it. Okay. So that's something which I wanted to share today. So next week when we resume back, we'll talk about a demonstration on uh, cloud data prep. All right. Thank you, folks. Let me stop the recording now.